Good morning, good evening, and good afternoon, depending on where you're joining us from today. We would like to welcome you to Devops Virtual Summit. Before we get started, we'd like a little bit of housekeeping. We do have subject matter experts with us today, so if you have any questions, please pop them in the chat window, in the Q&A window, and we will get to them as quickly as we can. Also, on the bottom left-hand corner of your console, you will find a resources area, so any links that I mentioned today would be accessible there. Right below the resources widget, you would find a survey. We would love to hear back from you, so please provide us any feedback you would have for today's session. Finally, this presentation is recorded and you will receive a copy of this presentation in your email within 48 hours. With that, I will hand you over to the speakers for today.
Hi, my name is Mike Chan, and I lead the Azure business here at Microsoft for Asia Pacific. We've got a great day planned out for you today, and I'd like to welcome you to the Devops Virtual Summit. We're going to be here to talk about how developers are really at the core of innovation in businesses today. We'll talk a little bit about security and the concerns that security brings to DevOps, but also we really want to talk about how DevOps can be used for organizational change and really to help bring companies into the future when it comes to digital transformation. And it's not just me talking about it, we're going to bring in some real live customer examples for you to keep things exciting. But first, I'd like to introduce you to one of our other panelists. We've got Sam, who's actually the sales VP for Github. Sam, could you introduce yourself, please?
Yeah, thanks so much, Mike. Hi, everyone. Really excited to be here with you. My name's Sam Hunt. I'm the VP of Asia for Github. Github, as many of you will know, is one of the world's largest open source collaboration platforms. It is basically where the world's open source is curated. And we work with organizations all over the world in the consumption of that open source, but also the commercial side of their development and how they actually innovate at speed. I think we all know in the 21st century, every organization is a software organization, and that puts software at the core of everyone's go-to-market. So yeah, our role in both transformation and business delivery is very much integral, in line with the developer being at the core of innovation and any organization's go-to-market.
All right. Thanks, Sam. I'd also like to introduce our other panelist. His name is Keith, and he's the Global Director for Cloud Infrastructure Engineering at ThoughtWorks. Keith, if you could please introduce yourself.
Thanks, Mike. As Mike said, I'm Keith Morris. I joined ThoughtWorks about 10 years ago, and that was around the time that the DevOps movement was just starting. It was also the time, so the reason I joined was because the continuous delivery book had just come out. So ThoughtWorks introduced the idea of continuous delivery, which is quite related to DevOps. So it's the idea of working with software delivery, with the people involved in software delivery, to make sure that every release can go through quite quickly, so that as people are working on the code, as developers are working on the code, they're building the kind of quality in and building production readiness into the software. So this was something I found quite exciting. And I joined and was working on projects where we would work with organizations across various industries and you know, around globally. And what we would be doing is we would be working with the other parts of the organization in addition to development to say, how can we make continuous delivery work? How can we make this idea of DevOps work, where everybody is working quite closely together to optimize the process of delivering software? And so what I found often was that we would be talking to people about how to manage environments. And this is where infrastructure as code came in, particularly where organizations were at that time starting to adopt virtualization. And as the years went on, they began adopting cloud. And so infrastructure as code was a technique that had been around since the beginning of the DevOps movement, to define how environments should look and how they should be configured as code to ensure that they can be consistent across. And so after working with organizations for a few years, I found that many people who were adopting infrastructure as code tools were struggling to work out the best ways to use those tools. And so that's where the idea of the book came from. I ended up writing this book for O'Reilly, Infrastructure as Code, The second edition of which is just finished writing and is going to press as we speak, so should be available by the end of this year, before the end of this year. So that's kind of been my journey with infrastructure as code, and within ThoughtWorks, the whole idea of continuous delivery in DevOps has very much been at our core. It's something that, because we started with Agile 25 years ago when the company started, it was a very natural progression to say, how do we take those techniques of bringing collaboration more closely together across, say, development and testing and the customer, and extend that into what we call the kind of the path to production, which is where DevOps really came into it.
Thanks, Keith, for the introduction. Now, I'd love to go to the first topic. DevOps has really been with us in the industry for a very long time. I remember when I was a developer 20 years ago, there was no such thing as developer operations. I was literally filling out paper forms to get my hands on a server. I spent hours making sure my laptop development environment matched the server. I would spend all this time installing infrastructure, making sure my versions of my libraries and frameworks were the right ones. And now, these days, you don't have to worry about any of that with the advent of cloud, with containerization taking off. And so we've seen this development of DevOps, not only from the open source days, right, when I was a founding member of the UCLA Linux user group, and people were collaborating on the Linux kernel from all around the world, all the way till today, where even proprietary software makers have integrated that DevOps mentality, the skill set, and the tools, to where one of the most important metrics that you'll hear about today is this concept called developer velocity. This is something we've been working on with McKinsey, where we tried to quantify what is the impact of not just DevOps, but this concept of developer productivity and actually organizational velocity when it comes to creating software. A couple of things we found out actually are that companies who have really high developer velocity indexes have higher productivity and therefore higher revenue growth and higher innovation. And all of these come together because these organizations mentally are thinking about developer operations. They have strategic leadership at the company level that think about developer operations. And obviously, they've got a great tool set. I'd love for Sam to also talk about what he's seen, right? And maybe to talk a little bit about what some of the issues with DevOps have been in the history and journey of DevOps in the past couple of years. Sam?
Yeah, sure, Mike. I mean, it's interesting because DevOps was really born out of the open source community, and I think GitHub was actually born to support the open source community. So we've been an integral part in the DevOps journey for a long, long time, and we're going way back when, sort of 13 years ago, when the three founders of GitHub were actually just looking at a better way for developers to collaborate together on open source projects, and that's continued to drive this need to remove the mundane and this need to push for automation and have checks. And that's really what DevOps is all about and where it's come from. And it's continued to integrate new tools and new capabilities into its ecosystem over the years, to the point now where the intention of DevOps is to get robust delivery, but really to free up your innovators, your developers, and allow those developers to actually focus on what's core to the value of what they're supposed to be doing, which is creating very cool and great innovative stuff that's going to help you drive your business forward. So, I think DevOps has come from a very simple strip back of mundane tasks and more control over process to really getting into the crux of automating the developer's life, freeing up the things that they shouldn't have to do so they can focus on the things that are genuinely creative and bringing new innovation to the world and bringing new innovation to your business. And, that really has come around. It's almost coined what we call now inner sourcing, which is open source was this great way that basically the 21st century was able to develop at the speed it was because of the open source community. Organizations now adopt that same methodology within a source. So when you think about DevOps, not only has it enabled developers to focus on the important bits, but it's also allowed them to share both internally and externally for greater and faster innovation, which is really important. And DevOps now just becomes the underlying enablement for developers to be brilliant, basically.
All right, thanks, Sam. This is really interesting. I think GitHub has been with us throughout the industry, and it's great to hear about how you've observed the development of DevOps here at GitHub. I'd like to kick it over to our other panelist, Keith, who has a unique view on this, I think. One of, again, the later developments in developer operations is this concept of infrastructure as a code. So Keith, I'd love to hear your take on kind of the development of DevOps over the last couple of years.
Right, Mike. So infrastructure as code, the techniques and technologies really emerged quite a while ago, actually. In the 90s, a tool called CF Engine came out, which was really embodied the concepts that we have for infrastructure as code. The idea of let's define what we want on, say, on our servers, using text files that we can put into a version control system and that we can apply continuously to keep all of our infrastructure in a consistent state and in a known state. And it was when DevOps emerged and cloud emerged in kind of the mid-2000s, say. This was when things really started taking off, and we saw new tools emerge, things like Puppet and then Chef emerged. And then as things went on into the, past that, as cloud really got the traction, we found that we needed ways to do more than just define what's on the servers, what kind of packages get installed and those kind of things. And we needed to define the broader infrastructure. So what are our networking structures? What kind of storage do we need to attach to servers? And so this is where tools like Terraform and CloudFormation emerged. And this really opened things up to be able to define environments in a very consistent way, and to be able to do more interesting things. As we do with code, with software and application code, we can now with infrastructure code, we can do things like write the code, apply it to a test environment, even run automated tests, and then progress that code along through each environment in the path to production, so that we make sure that every change is tested and integrated with other parts of the system, including applications. This has been a really exciting thing to be able to use those same techniques that we learned in software delivery and apply it to our infrastructure delivery.
Thanks, Keith. That was very insightful. I love the concept of infrastructure as a code, and I think your experience having talked to so many different companies really shows the journey that DevOps is on. I'd like to bring it now a little bit more to kind of today, right? This is not the best of circumstances. COVID, if there's a silver lining on all of this, is that it really is pushing companies to think about digital transformation. What's very clear is that companies that have digitally transformed have survived this pandemic better than others. And I'm not just talking about software companies, really. I'm really more interested in thinking about how energy companies, manufacturing companies, and even financial services companies have really digitally transformed, right? From the concepts of contactless payments and digibanks to how manufacturing can realign their supply chains as the world's borders kind of open and close. And even in energy companies where they've had to adjust to the new work patterns and transport patterns that every country is going through. One of the things that's quite interesting to me is that it's this concept really of every company is meant to be a software company these days. It's no longer just companies like Microsoft, right? And the shift, as you've heard, of the technologies and processes coming from the OSS world, but really only recently in the last couple of years, starting to come into the enterprise space and the enterprise scope. Right, so one thing I think that's quite interesting is really to think about what are those implications of how DevOps being introduced into enterprise scenarios impacts digital transformation. So So Keith, if you could talk a little more about sort of what are some of the things that our leaders here that are listening into us should think about when it comes to DevOps coming into an enterprise scenario?
Right, Mike. So the thing about what we've found with DevOps and continuous delivery and infrastructure as code is that in the early, kind of say 10 years ago, it was very new, and it was startups that were adopting this. And then over time, it's become more accepted in enterprises. So originally, it was seen as maybe not necessarily something for a serious business, and then it became adopted by more serious businesses. And then it became seen as something that, is it something we can use in like areas like finance and government? And actually, we found that that's increasingly becoming more and more viable. And the thing that we find is that it's not strictly about the technology. So organizations have ways of working that were developed for what you could consider the iron age of computing, when everything was physical and when it took a very long time to provision infrastructure, to configure it, and then to make changes to it afterwards. And so what people would do is they would start adopting these new automation tools because the benefits were really interesting and really exciting for organizations. But they weren't changing the way that they were using it. So what you have is you have these kind of siloed approach to delivering where there are handovers between teams, from one team to another, from one environment to another, and everything was done manually. And people started bringing in virtualization, cloud, infrastructure as code within those silos, within the same ways of working. And they found that they weren't really getting the benefits. That was still taking a very long time to get software delivered, to get new changes through, to add new features, to fix bugs even. Was taking a long time because of all of these handovers, in spite of having adopted new technologies and moved things to the cloud. So what organizations are realizing now is that they have to go further than that. They have to look at how are they organized, what are their working practices, and to basically take that DevOps idea of everybody collaborating across all the parts of the organization and really use the technology to across all of those groups, put those groups together to work on, okay, we're going to make pipelines to deliver our software and deliver changes to our infrastructure and to test those kind of things, to see that as a unified process rather than a series of very separate steps. And so at ThoughtWorks, we like to talk about this idea of tech at core, which is this kind of evolution that we've seen. We talk about, people talk about digital businesses, right? And the idea is that it used to be that technology and IT was seen as something separate from the business. It was not part of the core of the organization. It would be something that you might even try to outsource, and many organizations did outsource. And over time, what we've seen is that there's been this progression of seeing that actually technology is quite important to our business, to all businesses, no matter what domain you're in. It's quite central, and so it's coming to the point where technology has to be at the core of the business. It has to be something that the business sees as a strategic advantage, a way to connect with customers and other businesses and suppliers and to pull those all together into a very kind of tight a tight supply chain and to have the kind of knowledge of customers and to be able to satisfy them very quickly. So it's been an interesting journey, and it's really exciting where we've gotten to now.
Thanks, Keith. That's really interesting. I love the concept that DevOps is more than the technology or tools. I think that's a common issue that we face. In one of the most recent surveys that Microsoft has done, we also see that organizational support of the leadership is actually one of the biggest blockers to getting DevOps more across the entire organization. So I think it's really important to think about all the, call it, non-tech parts of DevOps as well. Sam, I'd love to hear your perspective as well. One of the favorite questions I get quite a bit when I talk to customers is, can I just buy DevOps? Is there something Microsoft just sells that will take care of this problem for me? What's your reaction to that question, Sam?
Yeah, it's an interesting question, Mike. Look, I think the misconception that DevOps is a product is often the shortcoming of an organization trying to transform. DevOps is not a product. DevOps is an approach. It's an enablement. And what's really important about DevOps is that it's not actually the only thing that an organization needs to change. Because DevOps was born out of a very unique culture, and that's one of openness and collaboration. Open source. which we all know and love. I think if you actually look at it, more than 80% of most organizations' code base is consumed from open source libraries not written internally. It's around the 20% that's actually the secret source. So in order to get success out of DevOps and genuinely innovate at speed, you really need to look at the culture that made it great as well and make sure that you embrace that. And that's kind of where we come into this whole inner source approach. And inner source without DevOps is collaborative chaos. DevOps without inner source is potential silos. So you really need both. In my opinion, a lot of people spend money on the DevOps side of things and assume an outcome will be there, but don't focus on the culture and the change that needs to happen within their organization. So the thing about changing to and embracing an inner source culture is it's not cost to your business. It's an approach that you need to allow your developers to know that you're supportive of, and it will yield great results. And, as I said, these developers they don't want to rewrite the mundane, the drop-down list, the library that extends a certain code that they're writing on. They want to get that from the open source community. So they're going to consume that, and it becomes a really, really important part of your ecosystem to ensure that culture extends to what you're building proprietary. So the 20%, I call it the secret sauce, although let's face it, McDonald's started sharing that sauce, that recipe for the Big Mac sauce online. But that's the 20% is the great. It's the bit that your developers deliver to you to make your go-to-market or your product or your consumer engagement unique. And that comes with the embracing of what they're already using, which is that open source community, which, open source community lives in the cloud, by the way. So when we talk about organizations being risk adverse to the cloud, well and truly more than half of your code is coming from there. And, obviously that's something that people need to really think about when they get sort of adverse to potential hosting in the cloud. And interestingly enough, GitHub actually gives you the option to do either or. In fact, we don't want to push an organization down one path or the other. 20% of your code, you may be more than happy living in the cloud because it's probably accessible via the cloud anyway. But then there could be a large degree of your code that you're really quite cautious of and you want to maintain behind your firewall or certainly on your private Azure instance. And that is certainly doable within the same tool, so you're not having to jump from tool to tool. So, I think organizations need to approach DevOps with an intention to transform their culture and be comfortable and open to the path that it will open up to them in consuming more cloud services.
That's great insight, Sam. I love how we're thinking about DevOps really as a process, a commitment from a company perspective, and sort of the shift of adopting sort of open source culture into a company. I think that's a great setup really to think about our next topic, which is really around security. When I was making software a long time ago, it was down to the individual who owned the code. There was a testing organization, and you really had this sort of, multi-month cycle between your software. But what DevOps and Agile has really done is really to make it as sort of a continuous process. And security is never going to go away, right? There's still criminal entities out there in the world. Vulnerabilities continue to be discovered, every weeks and every few months. So I'd love for you to talk a little bit more, Sam, about how security is handled within a DevOps scenario. Maybe share some of your thoughts around maybe more of the advanced security concerns around how do you handle remediation. I also get the question quite a bit of, hey, what if my source code is sitting out there outside my organization? What do I do then? Or I've also heard the question, hey, I have so many dependencies on these third-party open source software these days, and what do I do if I want to go faster than what the community is doing, right? I really have a need to push the community along. Sam, I'd love it if you could talk to some of those questions, given your experience at GitHub.
Yeah, thanks, Mike. Look, I think security is obviously very topical at the moment. People are thinking about it. They're exploring what to do. You know, the way GitHub treats security is there is a level of it that is just inherent in how we actually help protect the open source consumption the world over. So things like vulnerabilities and dependencies, scanning. You know, if a vulnerability is found within an open source library, we provide a space for those maintainers to actually work on creating the fix for that vulnerability and then ship it out. What's great is that for organizations that are consuming GitHub commercially, either on-premise or in our cloud service, they will actually get an immediate notification that that vulnerability fix is available. Not only will it make it available to them, but it will actually create the pull request that will allow them to apply that vulnerability patch to their software to correct the security vulnerability, you know. And that's really, really important because, you know, referring back to what I was talking about earlier, 80% mostly or thereabouts of your code is actually coming from open source communities. So, you know, it's important that you maintain a connection to that source of truth so that when things do change, you've got immediate access to that. And that's, you know, one of the definite advantages about GitHub being used with any organization because of that high level of open source consumption. You know, I'd also probably like to add that I think people have this fear of open source software. Is it secure? Oh, but anyone can see it. Let me tell you, if you want something to be secure, you want as many eyes on it as possible. And GitHub certainly does that. There's over 51 million developers working on GitHub on a daily basis. They're working in open source libraries, and open source libraries are publicly available and can be seen. Now, there's a misconception that, oh, well, if they're publicly available, someone could inject malicious code in there. That's not the case at all. The maintainers own the control of those open source libraries, and they maintain who can actually contribute to them. And even when something would happen, there's so many eyes doing review checks on that it's going to get picked up really quickly. So, in fact, I would say that open source software is probably more secure than potential proprietary software that might be consumed without you or anybody else actually being able to see it. So we have that side of security which we just consider bread and butter, and it's available as part of the standard GitHub service. But then we've got this service around advanced security. And advanced security is moving, you know, shifting security left and really looking at what's going on in your code base and analyzing that and allowing you to do things like custom queries so that you can actually look for potential malicious patterns that might have been written in by, say, a disgruntled developer, might have been skipped by a tool because it's not known about. That's where advanced security really comes into its own. And, you know, it's been a big investment for GitHub and a very important investment for GitHub because we recognize that 20%, that secret source, is super important. And the damage that a vulnerability within your proprietary code can cause you is substantial. So we want to ensure that we've got measures and platforms that allow you to protect that seamlessly without you having to think about jumping in and out of other systems. So, you know, I think if you consider your open source software consumption extremely secure, and when using GitHub internally, very automated for any potential issues that might be caught in the open source community, that's there. And then when you look at how you can more appropriately manage that code that's behind your firewall and be more extensive in your proprietary, GitHub Advanced Security comes in and supports that as well.
I'm glad you're thinking about these things, Sam. I think GitHub has had a lot of exposure to security concerns, and it's the same questions that we have not only at Microsoft, but also our joint customers out there as well. Keith, I think the same question over to you, right? What are some of the security concerns that you've heard from your customers, and also how do you recommend that they be addressed within the DevOps process and development cycles?
Yeah, so Mike, Sam was just talking about the vulnerabilities, scanning and that types of things when you're bringing in dependencies, which I think is it's at least to that topic of security and governance, which has often been one of the obstacles when it comes to the idea of do we do DevOps where we bring people together to collaborate on developing software, and we try to increase the pace by having things like continuous delivery and pipelines to deliver software and changes into production quite quickly. Do we have to sacrifice security for that? Are we compromising on things like, compliance with maybe regulations in many industries? Or just simply doing the right thing are we handling our customers' data responsibly? So what we find is that rather than being a trade-off where going fast means we have to make sacrifices there, what we're discovering is that actually being able to move quickly enhances and improves our ability to make better quality software and to make sure that changes are compliant. And the reason for this is that we can use the technology that helps us to deliver software quickly and deliver changes quickly. We can actually leverage that to say that every time we make a change, we trigger a stage in the pipeline that tests it. And we can add things into our test suite. We add things like, obviously, as Sam was talking about with the scanning of dependencies and making sure that we're not bringing anything from external sources that have vulnerabilities or have issues. So we can kind of check things and stop the line automatically there if it's not right. And we can do things like have automated checks of compliance. So this idea of compliance as code, where we actually build that test environment automatically using the infrastructure code, using deploying the application code, and then we run the checks and say, is there anything in that environment that is incorrect, that violates policy? Are there any ports open that shouldn't be open? Are there any software packages installed that shouldn't be installed? And so we can kind of produce those reports. And that helps people then to make the decisions of whether or not to approve the software, click a button to review those kind of reports, and then approve a change to go into production. It also creates an audit trail, right? Because we now have all these reports that we can show to auditors that say, this is the exact process that every change goes through. These are the tests that we run, the checks that we made, and these were the results of those for each and every change. So it actually helps us to build a much stronger case for compliance and for security than when we were doing things manually, where we're kind of having to depend on people to hopefully do the right thing, assuming that they have the time and the expertise to do that in the kind of crunch. So the whole idea of that continuous delivery pipeline is actually that people can spend time, rather than your experts in things like information security and compliance, having to spend their time focused on looking at individual changes going through. They can be looking at the process and the tooling that we have in place and the automatic checks to be constantly improving on those and having this kind of cycle of let's invest our time in our process for delivery rather than on incremental pieces of delivery.
I really do think policy and security as code is a great new area of innovation that I'm sure we'll hear more about in the upcoming months and years. Now I think that we can pull it all together. You've heard a little bit about the history of DevOps and how it's coming into organizations now and some of those concerns. You've heard a little bit about security and what advanced security means and looks like when it comes to developer operations. And also a little bit about sort of maybe the organizational changes of how do you make DevOps real within your companies and enterprises. I think now's the perfect time to hear more about customer examples, right? So maybe Keith, if I could kick it back over to you, if you could share a customer story about accelerating the development process or things like modern development skills. I think our audience would really find that helpful.
That's right, Mike. So I'm going to talk about some work that we did at ThoughtWorks with the Ministry of Manpower for Singapore. So what we've been working with them for a number of years now, and we did a particular project where we were helping them with how the system that employers and agents use to apply for and renew permissions for foreign domestic workers. So the system that they had been around for a while and was a bit difficult for people to use. So the ministry really wanted to create a more delightful experience for these people to interact with, and also to make the time for policy changes to get those through to be much quicker than they had been previously. So we worked with their teams it was not just about actually building the software, but it was actually about helping how their teams change how they build software, right? So this is the kind of that digital transformation thing of saying it's not just about adding new technology or it's not just about it's not just about like building some new piece of software. It's about the whole approach to doing this. So we took a co-source delivery approach, right? So in many cases, what happens is you have somebody, an external group, consultancy or what have you, build some software and then hand it over, and then your own organization is trying to kind of deal with that and trying to support it and maintain it. So what we do with our clients, what we did with the ministry in this case, was we did a co-source team. So we had some of our people come in and work with the developers and other people involved in software delivery within the Ministry of Manpower, and we worked across the roles to say, let's look at how you all are working on software, what your delivery practices are, and let's see what we can do to help you create those kind of tighter loops. So it's this idea of having teams that are outcome-based. So rather than having different teams for, say, developers and testers and infrastructure, how can we bring teams where those things are much more closely connected and everybody is working towards that goal of creating that much better system? And then having this kind of collaboration process between the developers and technical folks and the business folks and the outward-facing people who are really focused on what needs to be built. So we can have these tight loops. We can have these things where we go and we do surveys of existing users and find out how the experience is for them currently and where the opportunities are to improve. And then we can work where the technical people build the initial kind of versions of the software, maybe some initial screens, show those to the other folks, and get the feedback, and then kind of continuously improve. So it's a much more dynamic cycle. And then in addition to those kind of cultural and team practices, we look at the technical practices and what can we do there in order to support those cultural practices, right? So that the whole idea of the technical practices is that they support the ways of working. And so in order to get that kind of fast loop, we look at an evolutionary architecture. So rather than creating designs which are very static and like this is going to be the final design for our system, we use various techniques around evolutionary architecture to say, which build systems that will be easy to change during development and later on in past development. And a lot of the things that need to be in place to make that work are things like test-driven development, things like being able to refactor, things like pair programming to make sure that everybody has knowledge of the system and that we have kind of continuous code reviews happening as we write code rather than afterwards. And continuous delivery as the practice of getting our software changes ready for production and into a production-like system very quickly so it can be reviewed. And so these become baked in as just ways of working not just during development but also afterwards, so that the software is not just released and done, because what we've seen is that these days software is never really done, is it? We have to constantly go back and make improvements, make fixes, and respond to the changing environment. So when things happen like COVID, as we've seen, the need to be able to make changes to these kind of systems very quickly is important, because things are changing out there in the environment, and policy around things like migration and labor policies change very rapidly, and we need the systems to be able, we need to be able to change the systems very quickly in order to respond to that and to provide the best service possible as we can for citizens and for businesses. And so after having done this, we were able to go and do surveys of the users of those businesses and agents who were involved in getting visas and permissions for domestic workers, and find out what is the experience now with this new system. And it was great. We had some really good responses that people found this, it gave a really good impression, basically, of how responsive the government and the ministry was to users. So the outcome was really quite, it was great.
Thanks, Keith. You clearly have seen a lot of DevOps transformation in your role. Sam, I've got the same question for you. I think we'd love to hear a story from GitHub. You've got a tremendous amount of impact in the marketplace. Would love to hear about one of your stories around culture change, maybe one of your customers.
Yeah, thanks, Mike. I have a great story about Ford. So obviously we all know Ford, automotive organisation globally, but this particular story happens out of America. And Ford, like most automotive industry companies, had gone through and is going through continually this transformation Obviously, we think about cars, and 10, 15 years ago, what you thought about was, does it have, does it have aircon? Does it come in red? Can I get a sunroof? And that's why we bought a car. But in this day and age, we don't think about that. We think about the tech. What's in the car that's important? Does it have a really good UI for me to interact with it? Can I use voice control? Is it safe? Does it have monitors? Will it help me if I fall asleep at the wheel? These are the things that we buy a car for now. And that's all tech, that's all innovation, that's all software. Software's driving tin to do things. And Ford has gone through a great transformation, and they have a great team of developers working there. And this story is about one particular developer that I believe actually worked in the speedometer section. So the digital speedometers, writing code that managed the speed to the nth degree of accuracy that's needed to get something past government regulations. And turns out this particular developer was actually quite passionate about AI. And Ford, being a great adopter and embracer of open source, had actually started open sourcing code that they were using out on GitHub, which we absolutely advocate. We believe that if you can consume, that's great, but if you can contribute back with code that potentially others can benefit from, you'll benefit from their input as well. And that's exactly what was happening here. This particular developer was going home and actually working on those projects on GitHub, and the Ford folks were like, "This is great." They started committing some of the suggestions or changes that this person was actually putting on their project. What they didn't know, and this is the really cool part, and it really does draw the need to ensure that inner source is part of your strategy. This particular person was the same person working in the speedometer section. So they were passionate about AI. They would go home and work on AI projects on GitHub in their own time, and one of those projects happened to be something that was Ford's. So needless to say, over time they actually found out that this person worked for them. Now, that person is obviously focused more on the AI side of the business at Ford now. But what that says to me and to any organization is that if inner source is truly embraced within your organization and you have a genuinely open collaboration happening within your developers, that Ford developer could have seen that project internally and contributed, and you would have had an immediate acknowledgement of that developer's work and ability to deliver something for your organization. And that's really important, because I think what people tend to get fixated on is they hire a developer for a project or a code type or a product, and that's how you see that developer in relation to its values to your organization. But actually, that developer has substantially more skills than that. Almost every developer I know has a lot of passion around what they write, and they have a lot of passion projects as well. And when you're sharing openly and collaboratively code that you can securely within your GitHub enterprise, then these developers can actually apply those skills at work, and you're almost increasing your developer force by 40% just by being more open and collaborative. And I think that's a great story that actually represents the value of cultural change, not just DevOps. So hopefully that got you thinking, and it's a value to something that you can take away and take back to your organization.
That's a great story, Sam. I think we'll be hearing more and more about how GitHub is helping many more customers into the future. And now I'd like to share an example that's near and dear to my heart, not only because I love their food, but also love to see how they're transforming their business at Chipotle using techniques like DevOps. So as you can see, Chipotle is all about the food. And it is near and dear to my heart, not only because I love Mexican food, but this goes to show what it really means when you think about digital transformation and developer operations, right? Even a retail food industry company needs tons of developers, right? One of the big innovations that Chipotle has done is really take digital, online, e-commerce, food ordering to the next level. And so they've used tools like Azure, Visual Studio Code, and even the .NET Core to really accelerate the pace at which they're able to innovate their external customer-facing interface using things like DevOps. One of the best indications of how fast their innovation can get these days is this favorite quote that I have from Mike Smith, who's one of the developers there. And he highlights that he can get an environment up and running with permissions and security in less than 20 minutes, right? So there's less of this going back and forth about architectures and process, and really being able to innovate at that much faster speed to get a new environment up, to try to reduce ordering time, to try to increase the likelihood that someone's going to order, to increase the ability for them to remember the preferences of their customers, and doing all of this stuff in the online world. And as you can see on the left-hand side, they use a plethora of Microsoft and Azure technologies to frankly deliver better food faster to their customers. All right, so let's summarize what you've heard here today in our keynote here at the DevOps Virtual Summit. You've heard about DevOps and the journey that it's been on over the past decade or so, how it's entering into the enterprise and some of those concerns and also ways to address them. Obviously, security and some of the thought processes you need to build into your DevOps journey, and these great customer examples that you've heard from Microsoft as well as Sam and Keith. Now, you may be thinking to yourself, how do I get started? You guys have covered so much ground, right? And this is where I'd like to push out there how Microsoft, Azure, and GitHub can really help you in this journey of transformation. One of the biggest things, if you haven't heard or understood, is you have to create a DevOps champion in your company. Remember, the number one blocker to transformation is this sort of diffuse decision making. So make sure you identify someone who's really going to champion the DevOps strategy over the course of the next 2 to 3 years at your company. You want to set up some measurements, like how do you know you're making progress, right? You heard in the Chipotle example, for instance, that the ability to set up environments quickly that abide by policy and to quickly get your developers active in any type of project is one of those great measures. And with DevOps, you can definitely shrink that time to value. And make sure you're thinking about a tool set and software and processes that will really support you on that ongoing journey. And then lastly, you do need to set up employee training, because DevOps is really a culture. And culture is really about how your employees will think, act, and behave day in and day out. I'd like to call out, you can always visit Microsoft.com/learn, where there's tons of great content about DevOps. It's all free, and there's even code examples there that you can play around with so that your engineers, your project managers, your leaders can really get their hands on a couple of different DevOps scenarios and processes. So thank you very much for attending this keynote. I'd like to reach out and say thanks to Sam and Keith for their participation. Obviously, please stay tuned to hear the rest of these great sessions we've got coming up for you from our Microsoft DevOps Journey. Abel Wang, who's a principal cloud advocate, will be telling you about how Microsoft has gone through all of these scenarios before. Great customer story coming from Petronas and their DevOps transformation and journey, chaired by Annie and a couple folks from Petronas themselves. We also have Zachary, who's a cloud advocate, and he will really go much more deeply into one of my favorite topics, which is infrastructure as code. And then we'll close off with cloud container security by Vivek, who's actually working at a company called Pentester, who's seen a lot of examples of how do you have to build security into your DevOps process. So thank you very much again for listening to our keynote, and please stay tuned for the next session.
My name is Abel, and I'm so excited to be here today to talk about Microsoft's DevOps transformation. But before we begin, let's do a quick introduction. So again, my name is Abel, and I'm a principal cloud advocate and the DevOps lead here at Microsoft. I've been writing code now for over 20 years. It's what I love. I eat, drink, and live writing code, right? It just makes me happy. And I've been doing DevOps for quite some time too. And right now, I'm super lucky because I lead a team of 5 DevOps practitioners, where our sole charter is to help everybody get into Azure using DevOps best practices. Now notice, I didn't say you had to use Microsoft tooling, right? I didn't say you had to use Azure Devops Services or GitHub Actions, because Azure literally doesn't care. Azure is an open system, an open platform, so you can use whatever tooling you want to get into Azure. So what that means is, guess what? You can use whatever you want, and we as a team, we just want you to help get into Azure using DevOps best practices. So we are a resource. Please do use us. So how do we get a hold of us, right? How do you get a hold of us? Well, don't email, because I really hate email, and I don't read it very often, so I'm about 2 weeks behind. But I'm on Twitter all the time. So if you tweet at me, and especially if you hashtag it LOECDA, that's like our bat signal. Me and my team, we will see that, and we will answer your questions. And if we can't answer your questions, we will find the people at Microsoft that can. So again, we are a resource. Please do use us. All right, so before we talk about Microsoft's DevOps transformation, we should probably level set on what DevOps is, because if you ask 10 different people what DevOps is, you're probably going to get 20 different answers. So at Microsoft, DevOps means something very specific to us. DevOps is the union of people, process, and products to enable the continuous delivery of value to our end users. So I said this really carefully because every word has meaning, right? Notice I didn't say continuously deliver code, because what will that give us? Piles and piles of code sitting on a source control server somewhere. That doesn't do anybody any good, so who cares, right? And notice I didn't even say continuously deliver features, because we could be delivering feature after feature, sprint after sprint. But again, if this is not what our end users need or want, why are we wasting time, right? It's about continuously delivering value. So why is this so important? Well, the bottom line is the speed of business is so crazy fast today that the only way dev teams can keep up is if they adopt DevOps best practices. And if they don't, they won't be able to keep up. So here's the sad truth. If you don't adopt DevOps best practices, your competitors, they either have or they will. And once they do, they will out-innovate you. And when that happens, you become obsolete. And none of us wants to be obsolete. So this right here is the exact position Microsoft found themselves in around the 2010 timeframe, right? Back then, we were still delivering code once every 3 to 4 years, but our competitors were innovating faster, and we were losing customers. And this was a very scary place for us to be, and we knew we had to change. We knew we had to adapt, shift, and adopt the DevOps best practices. However, this was very difficult to do, and one of the things that we had to learn is this. If it hurts, you need to do it more often. So when things hurt, we usually tend to avoid them, right? And what really hurt for us was pressing that deploy button. Because every time we press that deploy button, guess what? Things would break. So what did we do? It hurt, we tended to avoid it. So if I had some changes to check in, maybe I had like 20, 50 lines of code to check in, I would avoid deploying. I'd say things like, well, why don't we wait until the end of the sprint? Because I knew if I pressed deploy, things would break, and then it would be a big headache, right? Eventually it got pushed out even from the end of the sprint, and we'd be like, well, why don't we deploy at the end of the month, or maybe at the end of 6 months? I might even get pushed out all the way to the end of the year even. And now what was just 50 lines of code, now it's become thousands of lines of code that changes. So of course, if we try to push into production, that just makes everything so much worse. So of course things would break. So this was a very important lesson to learn, which is if it hurts, don't avoid it, do it more until you get better at it. So that's what we did, right? We built out these DevOps pipelines, we pressed deploy, and guess what? Everything broke. But that's okay. We fixed it and tried it again, and still everything would break. But slowly, over time, iteration after iteration, we slowly got better until eventually today we can press that button and we know our deployments work because it just works every single time, like clockwork. So how cool is this? Remember, there's that saying in our industry where they say don't deploy on Fridays, because if you deploy on Fridays, then you're going to have to work all weekend to get everything working. We don't worry about that anymore because we know our pipelines work. I can press that button on Friday, we can deploy, and everything just magically works. Why? We know it because we do it over and over again. We found what hurts the most, which was our pipelines, and we slowly improved upon it until today, they just work. All right. So our DevOps story begins when we first started, right? Microsoft came into being around the 80s, 90s, and the early 2000s. We dominated, right? But the way we did things was interesting. We would deploy new code where we put out a new product every 3 to 4 years. So every 3 to 4 years, there'd be a new version of Windows or a new version of Office or SharePoint, or for my team, a new version of TFS. And that worked great for us back then. We were very waterfall-like. But again, the world started moving much quicker, especially right around the 2010 timeframe, and we knew we had to make changes. And one of the places we had to make changes is our organizational chart. So this picture here, I love it. I think it's hilarious. The first time I saw this, Scott Hinselman showed it to me. And yes, it is a joke. But like all jokes, there's some grain of truth to it. So if you look at how Microsoft is organized in this cartoon, it has all these little islands, right? Or all these big islands. And each island had deep hierarchies within it. And each island for us would represent a product group. So one of these islands would be the Windows team. One of these islands would be the SharePoint team. One of these islands is the Office team. And one of these islands would be the Azure Devops Services team or the TFS team. And that would be my team, right? So that was great. We had all these separate teams, but they were all islands into themselves, because we got to decide exactly how our team wanted to be structured. We got to decide how our team functioned and all of that. But the best part is each one of these teams had guns pointed at each other, right? And we really were like that, where we were hyper competitive against each other. So back when we first came about, we created this culture because we thought that if we fought each other tooth and nail and competed against each other, by the time the product would go into production and go out to the public, the product was forged in fire, which would make it better than ever before, right? So that was our thought process. And back when we were deploying code every 3 to 4 years, that worked out pretty good for us. However, if you're trying to move quickly, and you have all these guns pointed at each other and you're fighting each other constantly, you are not going to be able to move quickly because you're constantly fighting. And that's exactly what we found. We created this very toxic environment where everybody fought with everybody else. And to really be successful at DevOps, you need to be collaborating and working across teams constantly. So this was a huge blocker for us. Luckily, around the same time frame, we got a brand new CEO by the name of Satya Nadella. And he said, you know what, this worked great for us before, but if we continue down this path, we're going to become obsolete eventually. So what we want to do is create something called the One Microsoft Initiative, where we are one company and we're all working together to be successful no matter what it takes. Put your guns away and everyone needs to work together. He also had the idea that we should have one engineering system. So by that, I mean our build systems, our release systems, our source control systems, our tools, so on and so forth. And back in the day, we as a group, as each individual product groups, we could pick and choose exactly what type of tools we want, which meant we all used different tooling. And that meant it was extremely difficult to collaborate with people that were not in your team because they would have a complete different source control system, a complete different build system. You didn't even speak the same language when you worked across teams. It became crazy difficult. So Satya said, one of these things we have to do is create one engineering system. So then he asked an interesting question, which is, which system should we use? And then he came up with the idea of, don't we have a DevOps system in-house? And that made me super happy because I was like, yes, that's Azure Devops Services, or back then it was called TFS, because that was my team. But then Satya asked a very embarrassing question, which is, who at Microsoft is now using TFS? And the answer was no one, not even the TFS team. because we use other systems. And Satya said, this is ridiculous. The only way for us to build a world-class DevOps system is if we use it ourselves, because then we'll know what works, what doesn't work, and we can go in and fix what doesn't work. So that's what he mandated. Across our entire Microsoft, we're going to use one engineering system, and it's going to be Azure Devops Services. Now, for those that don't know, Azure Devops Services is everything you need to build your software, for your software project. So you have ways to track your projects. You have a CI/CD system. You have your source code repository system. You even have things like a manual test case system and also an artifact repository. So again, everything you need to run your software. And we know this works because I love this slide because it shows the numbers that we use. And this is from 2 years ago. So the numbers today, they're even bigger, right? But how many engineers use Azure DevOps Services? 96,000 engineers every single month, every single day. How many builds happen per month? 6.3 million builds happen. How many work items are viewed every day? 5 million work items. How many deployments happen every day? Over 163,000, right? So we know Azure DevOps Services scale because we use it internally. And these are just our numbers. It's not adding our customers' numbers who use Azure DevOps Services as well, right? And our numbers, our version of Azure DevOps Services is exactly the same as everyone else's. It's not a special version. So yes, we know it works because we use it internally. All right, back to the story. Our journey, like I said, we used to deliver new software every 3 to 4 years, right? Around the 2010 timeframe, we started realizing we were being out-innovated, and it was really bad, right? So let me give you an example. Around the 2008 timeframe, we came up with a new thing for work item tracking. That was the team that I was working on then, and I was very happy. I told my friend, he tried it out, and then he called me on the phone and said, hey, that's a neat feature you wrote, but there's a bug. Bug? I don't write bugs, right? But I jumped in there, checked it, turned out there was a bug. So I fixed it, checked it in, called up my friend and said, hey, I fixed the bug. And now you can see the fix in 3 years. Right? That's crazy. However, that was the speed we're working at. So we knew we had to increase our speed. So around the 2013 timeframe, we increased our cadence. So what we did was every 3 to 4 months, we would send out a service pack to our end users and said, install this. But this put us in a very weird spot because it made us both move too quickly and also too slowly, both at the same time. And let me explain what I mean. We were moving too quickly because every 3 to 4 months, we expected our customers to take this, install it. But to install it, they would have to bring TFS down, install it, bring TFS back up, and usually TFS probably wouldn't work. So then they'd have to tweak it to get it working. So all told, TFS would be down 1 to 2 days. And they were like, wait, you want us to bring our engineering system down every 3 to 4 months for 1 to 2 days? Are you crazy? We can't do that. So then they would stop installing these service packs and they would fall further and further behind. But the sad truth is, even if they installed these service packs every 3 to 4 months, our competitors were still moving quicker than us. So we knew we had to move even faster. And to do that, we had to go into the cloud. Because by going into the cloud, that now lets us move at cloud speed. And what do I mean about cloud speed? Every 3 weeks, like clockwork, new features just magically light up in Azure DevOps Services, like clockwork. And what we don't tell people, but I'll tell you guys because I think it's super cool, every day, multiple times a day, we are pushing into production, we're pushing bug fixes. So every day we're pushing into production. Why? Because we can, because we know we can move at that velocity. So we are so advanced DevOps-wise. I love showing this. This is our definition of done, and it's a very mature definition of done. So not only does a user story have to be code complete, and not only do we have to have a unit test that tests this particular user story, we're not considered done until it's pushed all the way into production. And it's still not considered done until it's gathering telemetry and sending that telemetry back to us, right? That's how important telemetry is. Now, this is a very advanced definition of done, and people always ask me, hey, should that be our definition of done? And I'm like, no way should it be, right? You never start out with something crazy. Because remember, DevOps is a continuous journey of improvements from one iteration to the next iteration. So that's what it's about. After your iteration, you need to figure out, hey, what hurts the most, and just fix that. And slowly over time, your definition of done will evolve until it becomes more mature. So don't try to bite off too much at once. All right, something else that we had to change is our team structure. So our team used to be structured like this. We have program managers, devs, and our testers. But we had a very toxic relationship between our devs and our testers. In fact, they were fighting each other all the time. Now, as a dev, I actually viewed my QA team as my enemy. I was fighting with them all the time. And let me give you an example. At the beginning of the day, I would go into work and QA would give me a bug report, right? All the bugs they found from my code. And I would immediately get really mad. And then I'd start working through each bug one by one, trying to prove that I wrote my code correctly, and it's because they tested it wrong, which is ludicrous. Why did I view my QA team as my enemy? My QA team, they're my first line of defense and my best line of defense. But we had this toxic relationship that just existed at Microsoft. So part of that toxic relationship was caused by us as well. And I was part of this, and we didn't mean to. But oftentimes I would interview somebody for a position, and I'm a dev lead, so I would say things like, well, this person was great, I liked them, but I don't think they were technically quite strong enough. But they'd be great on that QA team. So we created this second-class citizenship with our QA teams. And again, that helped with this really toxic relationship we had. So what we needed to do, what we ended up doing, is we collapsed both teams and said, you know what, there's no longer devs, there are no longer testers, you are just engineers. And now, quality is everyone's responsibility. Quality is every engineer's responsibility. So that meant as a developer, I had to upskill. In fact, everybody had to upskill, get cross-trained and get upskilled. Where as a dev, I had to learn how to build quality into my app as I was writing it versus just writing my code, throwing it over the fence, have QA find my bugs, and then try to tack quality on at the end, right? So I had to learn things like how to write good unit tests. I had to learn how to write code in a testable manner. I had to learn things like how to write automated UI tests and things like that. And on our the QA side, they had to learn how to write code as well. Because ultimately, before, they were just pure functional testers that clicked on buttons. So they had to learn coding. Now, not everyone could make this change. So we suffered attrition. It was pretty rough to make this change. And my attitude was terrible about this as well. When we first started getting trained for this, I pushed back really hard because I thought this was crazy. I'm a developer. I write code. I am not good at testing. My brain is not wired for testing. It's not in my DNA. I came up with all kinds of excuses until finally leadership came up to me and said, you have to change your attitude. And if you don't change your attitude, you're going to have to find a new job. I got really angry. I got very huffy. And for a while there, I thought maybe I should find a new role. I can easily find a new role. But then I looked at how much stock I had, and I went, maybe I should change my attitude. And when I did, that's when everything changed, right? I literally had to learn how to write code again. I had to learn how to write code in a testable manner. And I had to learn about quality. And this changed everything. But again, not everyone can make this change, and we suffered attrition. Leadership didn't know how much we would lose, like how many people we would lose, but they knew we were going to lose a lot. And we ended up losing 20%, which is a crazy amount, right? Nobody wants to lose good engineers. And we lost a lot of very good, very senior engineers who could not make this change, both on the dev side and the QA side. But leadership also knew that this was a price they were willing to pay because now they could replace these people with other engineers that bought into this mindset. And now we could move faster than ever before. Not just a little bit, but way faster. So this was a heavy price, but this was a price leadership was willing to pay. The other thing we did is we restructured our org chart and flattened everything out. Remember, we had this deep hierarchy? Well, that made it extremely difficult to make changes because in one particular feature, if you wanted to change that feature, it would span multiple teams, right? So to coordinate between them all, that became difficult. So we created what is called feature teams, where one feature team would own one feature all up. So they would own everything about it, right? The other thing is that this allowed them to be so much closer to our customers. Whereas before, if our customers wanted to give feedback about a feature, who would they go to? Because again, this feature spanned multiple teams to implement. But now there's a program manager that you can just reach out and talk to about your specific feature. It was so much easier for our customers to talk to us. In fact, now they can talk to us in so many different ways. They can talk to us through Reddit. They can talk to us through user voice. They can talk to us through Stack Overflow. They can even just use Twitter. Our program managers, that's all public knowledge. You can just tweet directly to one and say, hey, I love this feature, or this feature sucks, or can you fix this, blah, blah, blah. And by being this close to our customers, we can gather that feedback, and that helps us know, are we delivering value? And we can start delivering value faster than ever before. So this was super cool. But of course, by structuring our teams this way, right, by having these feature teams, that forced us to re-architect our application in a different way as well. So before, we architected our app in layers, right? You have the UI layer, the API layer, a data layer, and our teams were structured that way as well. We had teams that were UI teams, teams that were API teams, teams that were data teams. And again, there were so many teams. For one particular feature, it would cross through lots of different teams. Difficult to get work done. A lot of coordination was involved. So now we created these feature teams. And so now, instead of designing everything in layers, we have to design things in slices. So now one team would own everything all up, the UI layer, the API layer, the data layer. They would own, gathering requirements to figure out, are we building the right things? They would own quality for this particular feature. They would own even the CI/CD pipeline. So they would own everything about this one feature. And again, because of that, we were so much closer to our customers, and now we are so much more agile. We can make changes within a feature. We didn't have to coordinate between all these other teams. It was so much faster and better for us. Now, each feature team, to give you kind of an idea, we have about 800 engineers. We have about 60 some of these teams. Each team has about 10 to 12 people in them. And each team is self-managing, so they get to decide what they want to do. And we have teams on the East Coast of the United States, West Coast of the United States, out in India, all over the world, right? So this is very, very global. Now, before COVID, we required you to be with your team, right? So you could join whatever team you want, but you had to be co-located with your team. And the reason why we did this is because what we found out, we tried it differently. We tried it so you can just join whatever team because we have remote capabilities, but it became too difficult to schedule and coordinate between people from way, different time zones. It became very, very difficult. So we said you can join any team, but you have to be co-located. In this way, you can just have all of your meetings, you can coordinate, it's much easier to do it. In the COVID world, we are 100% remote. You can still pick whatever team you want to be on, but you have to be in a time zone close enough where you don't have these hurdles of coordinating, right? So that's still important to us. But it's kind of neat. Each one of our feature teams, they are independent from each other. So they're self-managing. So they're autonomous. But they're not 100% autonomous. Otherwise, it would be complete anarchy, right? It is controlled. So we have what we call aligned autonomy. Right. So there are certain things we align on, like the type of sprints that we do. You can choose what version of Agile. One team can be Scrum, one team can be Kanban, so on and so forth. I like Scrum. I'm a Scrum purist. But those things you can choose, but then there are certain things that we have to align on. Now, once a year, we have what we call the Great Sticky Yellow Note exercise, and this has been an amazing, successful experiment that we ran, which is every year, team members are allowed to pick which team they want to be on. So once a year, we have this exercise where the program managers, they say, join my team. My team's the best. We're using the latest JavaScript framework of the moment. Look how many customers we have. Look at all the cool technology we have. Join my team. And as engineers, we say, this is my first choice. This is my second choice. This is my third choice. And then based on availability, we get to pick which team we want to be on. Now, the interesting thing is most engineers don't want to change teams. They don't like change. They love the team they're with. They love the culture that is built. They love the people, right? You build friendships. But 20% of the engineers do want to change. And just by giving engineers the choice, this makes them so much happier. So again, this is one of those experiments that we ran that became incredibly successful, and we still do this today. All right, so other things that we align on is our sprints. Our sprints are 3 weeks long. We used to have every team can pick their sprint cadence. That turned into chaos trying to coordinate between all 60-some teams. Too hard. So now we say we start at the same time, we end at the same time. Our sprint length is 3 weeks. Why 3 weeks? We tried 2, and trying to coordinate through all 60 teams, there just wasn't enough time, it felt like. We tried 4. That just wasn't agile enough. It just felt like the sprints just lasted forever. We tried 3 weeks and we said, hey, that felt pretty good. So that's where we are, right? We're actually trying to implement 2-week sprints now, but that's a work in progress, and I'll talk about that more later. So how do we coordinate? At the beginning of the sprint, we have the sprint planning meeting. At the end of the sprint, we're done. When we are done, we press the deploy button, and we deploy at the end of every sprint. If you don't deploy, what we found out is things just don't get done. And not because developers are lazy or engineers are bad, but by not deploying, certain things just don't happen. So we have a rule. At the end of the sprint, always deploy. Now, our deployments take a long time because we try to deploy very carefully throughout the entire world. So we do something called safe deployment, where you first deploy to a small segment of the population, then a little bit more, then a little bit more, then a little bit more. So because of that, our deployments take up to a week long, right, from pressing that button. So at the end of the sprint, we press that button. The deployment can take up to a week, so sometimes it bleeds into another sprint. But we've worked through that, and that works as well. So this works pretty well for us. Trying to coordinate all of our teams is difficult as well, because you can't all sit in the same meeting, especially with all the different time zones and stuff. But at the beginning of the sprint, we create a sprint plan that says what we're going to do, and we email that to everyone. And at the end of the sprint, we say this is what we've accomplished, including a video of what we've done. So this has been an extremely good way for us to communicate what's happening across all 60 of our teams. So this is what it looks like, right? At the beginning of the sprint, we say this is our sprint plan. We use Azure Devops Services to track our work, which means this email just pretty much gets generated automatically. And at the end, we say this is what we accomplished, and we create a video. The only rule for this video is it cannot be produced, right? No smoke and mirrors. It needs to be the real thing. So that's pretty cool. And again, this has been a great way for us to communicate what we're doing, each team. And it's been a great way for leadership to see everything that's happening across all the teams. Before, we used to send this email out at the user story level, but what we found out is at the user story level, there was way too much detail. Most people didn't have the context to understand it at that level, so we moved it to the epic level, and now it's so much better. There's a lot less chatter. It just works out nice and clean. Now, across our teams, the way we do planning, first we have sprints, which is every 3 weeks. We have a quarter, which is every 4 sprints. We've got a semester, which is 6 months, and then, of course, we have our yearly plan as well. Now, I'm interested in sprints and quarters, right? Because a sprint, as a team lead, that's what I'm worried about. Each sprint is 3 weeks long. I worry about my product backlog, how to prioritize that, and all that stuff. And every 4 sprints, I meet up with my sister teams, and we have meetings as well to help shake things out, right? Because these are sister teams, so these are teams where we share code or we're very closely related. We talk about things like what we've worked on, what we're going to be doing, and then a lot of information starts to shake out, right? So for instance, things like, oh, we're going to be changing this API, you use this API as well, how do we coordinate, things like that, or even things like, oh, my sister team, they need a widget for their UI. Turns out I've already built it in my last couple of sprints, why don't you just use it instead, right? So a lot of useful information comes out of this, out of these quarterly meetings. Leadership should worry about the semester and the strategy, because at every semester they have a giant meeting and they reprioritize our yearly plan as well. So every 6 months that gets updated. We even have rules in place where our leadership are no longer allowed to look at our sprint backlogs. Why? Because before, every time they looked at our sprint backlog, they would want to micromanage. They just couldn't help themselves. And the problem with that is that leadership did not have enough context to micromanage effectively. So because of that, we would waste a lot of time explaining to them why we couldn't do things the way they wanted us to, give them enough context, and we wasted so much time. So eventually we just finally said, you know what, leadership, you're not allowed in our backlogs because we don't need you to tell us how to manage our little section here. We need you to guide us. We need you to give us strategy, long-term strategy. That's what we need you for. So this was difficult for leadership to give up this control, but they realized the truth in this, and they realized that they were really slowing down progress, so they agreed to it, and now this has worked out really well. The other thing we had to fix is how we did quality. So before, we would write code until you finally got done with your code complete, pizza party time, right? But you weren't really done, because this is when QA would start testing your code, and that's when they would start finding the bugs. And now the dotted line, that's your bug count or your debt count. And because of that, it would build up and they would find a mountain of bugs, and then you would burn down your mountain of bugs, right? So this chart here is best case scenario, because most of the time there are so many bugs you can't burn them down fast enough or even get all the way done. Hopefully you just get quality good enough. And then the next iteration you do the same thing, and this bug count just gets higher and higher. So we've all been in this position where an application is so fragile, every time you try to make a change, other things break, or you fix a bug and then 5 more things break. And we've even been in that situation where our application is so fragile we can't add any new features because constantly we're just stitching things together and just making it work, right? So that's technical debt out of control. So that cripples innovation. So we needed to make sure that did not happen. So what we did is we came up with a rule that said at the end of every sprint, you must burn down all of your bugs. You cannot carry bugs from one sprint to the next. And we're so serious about this, we created something that we call the bug bar or a bug cap, which is every engineer on your team, they can only carry 4 bugs from one sprint to the next sprint. Why 4? Because in theory, we, or at least our engineers, can burn down 4 bugs within one sprint time frame. So the idea is we can spend one sprint and our product would have 0 bugs, right? And we are so serious about this, we have this bug bar. We actually have a report that shows what the bug bar is for each team. And if a team is over the bug bar, they're not punished, but they're not allowed to take on any new features. For the next sprint, they just have to burn down their bugs. And this isn't a punishment, right? This is just a way to make sure that we do not carry debt from one sprint to the next. And because of that, our quality is so much better than ever before. The other thing that we had to learn is what you measure really matters, right? So you have to measure very, very carefully, because if you measure things that don't matter, that drives behavior. So we have a mantra at Microsoft, which is measure the outcome that you want to happen. Don't measure the output, because if you measure output, your engineers are going to game the system and those numbers don't mean anything anyway. So to give you an example, things like code per coverage, right? Percentage of code coverage, that's actually an important number. But if my bonus was based on code coverage, do you know that will be 100% every single time? But that doesn't necessarily mean my unit tests are doing anything, right? Super easy for me to write a test that just touches every line of code but doesn't test anything. That's the type of nonsense developers end up doing. So don't measure the output, measure the outcome that you want. So what's important? Things like mean time or cycle time. How long does it take to start work and then the work shows up all the way in production? Or how long does it take to have an idea and have that idea cycle through everything all the way out to production? How quickly do you find live site incidences in production? How quickly, once you found it, before you get the fix out into production, right? Things like that become really, really important. So we still do gather performance numbers about our individual engineers. But the important thing is we don't use these numbers to reward or to punish our engineers, right? I use these numbers to try to help my engineers. Because again, if I try to use these numbers to punish them or to reward them, our engineers will just start gaming that system. Why? Again, it's just the way engineers are wired. It's that mathy brain we have. And there's nothing we can do about it. So I try to use these numbers to help. Right? So for instance, if I notice productivity has dropped for one of my engineers on my team, I will go up to them and I'll talk to them and I'll say, look, your productivity has dropped. I know this, but why? Is it because we're using a new JavaScript framework? We seem to trade those out every couple of days, right? Do you need more training? Because if you need more training, I can get you more training. Or is it just because you needed time to get used to it? So next sprint, you're going to be fine. If that's the case, carry on, right? Or are you suffering problems at home? Is bad things happening at home? Do you need time off? Like, I can do that as well. Or do you need resources to help? We can have resources at Microsoft that really help. So again, I don't use these numbers to punish. I use these numbers to help my engineers. Now, of course, this leads people to always ask me, how do you make your engineers do the right thing, right? Well, guess what? Our engineers end up doing the right thing because we make them feel the pain of their bad code. So what do I mean about that? I'm that guy that writes code at a crazy fast speed at Microsoft. I'm really, really fast. In fact, I'm so fast, I usually never even feel the pain of my code. Because I write the code really quickly, throw it over the fence, QA finds my bugs, but I'm off doing something else. And by the time QA comes back with my bug list, some poor junior dev has to fix my bugs for me. To the point where I don't even see my bugs, right? I think I'm God's gift to programming. And I'm not, right? I'm human just like everyone else. But I never felt the pain of my bad code. And now we do. We have another mantra at Microsoft, which is if you write it, you need to run it, right? So what this means is, what's the worst thing that could happen to us? If we get a live site incident, it's really bad because Azure Devops Services, the team that I'm associated with, our application runs, other companies use it, and if we go down, they can't do their business, right? They can't do their builds. They can't do their builds and releases. They can't plan, things like that. So we can't go down. So if something bad happens, Scott Guthrie gets called, which is our EVP. He's Satya Nadella's right-hand man. And he gets on the phone and starts calling all of the management chain all the way down until it reaches the program manager who is in charge of the feature that's causing this live site incident. And then this program manager is going to call the 2 people on his team that are on call. And there are 2 of them, and it rotates every single sprint because it's so horrible to be in this role. You get on call, you get this call that there's a live site incident, and it happens at 2 in the morning because it seems like it doesn't matter what time zone you're in, it always happens at 2 in the morning. So you get this call, you join this call bridge, your entire management chain is on it, and you get Scott Guthrie asking you every 2 minutes, did you fix it? Did you find out what's wrong? It is so stressful and horrible. And you are not allowed off this call until you slapped a Band-Aid on the problem and you made the problem at least temporarily go away. But you're still not allowed off this call bridge until you figured out the root cause, and then you come up with a plan where you make sure this never happens again. And only then are you allowed off this call bridge. So because it's so horrible, we all do the right thing to make sure we never get on this call bridge ever again. So every developer check-in has to go through a pull request or a code review. So when I see somebody has checked something in and it needs to go through a pull request, a code review, I jump on it really quickly and I'm reviewing every single line with a fine-tooth comb because I don't want my teammates' bad code to put me onto this call bridge. I'm also not only just looking at their code, I'm looking at their unit tests as well because I know that their unit tests, that's what's going to protect me from getting on this call. So I'm looking at everything super, super carefully. Right? So you need to feel the pain of your own bad code. And once you do, our teams self-police and we end up doing the right thing. So that right there is what I mean about feel the pain of your own bad code. If you run it or if you build it, you need to run it. So super, super important concept. All right, another thing that we did is we changed our branching structure to help us move quickly. So before, we used to have a lot of long-running branches, right? We'd have a dev branch, QAT branch, QA branch, UAT branch, long-living feature branches, so on and so forth, our production branch. The problem with these long-living branches is anytime you have to merge from one branch to another, at some point, eventually, you're going to get a merge bomb. You're going to get merge conflicts. And these merge conflicts, they were not easy or cheap or quick to fix. They were so difficult. They were such a pain. We needed to get rid of those. That really slowed down our velocity. So what we did is we adopted trunk-based development, where if I get a user story to do, I would spawn a branch really quickly, right? But this would just be a topic branch. I would wrap everything that I did in a feature flag, and then I would merge quickly back into the master branch or the main branch. So what this meant is there are no long living branches. And by having no long living branches, we wouldn't have these merge bombs or these code conflicts. And so that made our lives so much easier. And our code was protected because we used feature flags to wrap everything up. Now, because we wrapped everything up in feature flags, this gave us the added benefit that it separated our deployment of code from our releasing of features. And this brought up all sorts of advanced DevOps techniques that we could use, right? We could do blue-green testing using feature flaggings, or we could do safe deployments or canary deploys and things like that. And rollbacks became super easy because we could just turn off the flag. So that really helped us. I'm a huge fan of feature flags. Of course, feature flags comes with a price as well, because basically they're just if statements. So the more flags you have, the harder it is to test, and the more complex your code becomes. But for us, feature flags, the price you have to pay for feature flags, that tax, it's so worth it because the benefits that you gain way outweigh the price that you have to pay. But we do have rules in place, right? Once a feature reaches production full time, you need to clean up your feature flags. No ifs, ands, or buts. Because if you don't and just leave your feature flags around, it clutters up your code and things can really spin out of control. But again, this was great for us. All right, finally, these are the changes that we did, right, from before to after. And some of them we jumped in more detail than others, and it's worked out extremely well for us. But whenever I tell the story, it really seems like, hey, we did this just like that, right? Microsoft figured it out, and it was super easy. Nothing could be further from the truth. It was very, very difficult to do, and it took us a very long time as well. And in fact, we're still iterating and getting better from one sprint to the next. Because remember, DevOps is not a one and done. You don't just buy DevOps and then magically you have it, right? DevOps is a process of continuous improvement. It is a journey of continuous improvement from one sprint to the next sprint, where you ask yourself, what hurt the most? And you fix that one thing. And then at the end of that iteration, you look at it again and say, what hurts the most? And you try to fix that as well. So it's a continuous journey of learning, and it never ends. All right, thank you all so much. This has been Microsoft's DevOps Journey. Hopefully, it's giving you some inspiration. It's giving you some of the lessons we've learned. It's giving you some ideas, and it's giving you some ideas on what not to do as well. Thank you all so much. If you have questions, feel free to reach out to me on Twitter at AbelSquaredHead. I answer all my questions. Thank you all so much.
Hi, I'm Annie Matthew, Head of Developer Relations at Microsoft Asia Pacific. We're going to talk about DevOps, and I have with me a very special guest, J.K. Lok, Head of DevOps Practices, Digital Engineering, Petronas. Welcome, Lok.
Hi, Annie. Thank you for having me.
Thank you, and I'm looking forward to chatting with you. Can you tell me a little bit about the Petronas journey with DevOps, where it started and what really initiated the change?
Just like any, any tech organization that has a bit of history, we Petronas were working in a very traditional waterfall manner. To be frank, I never liked it when I joined 2 years ago. I felt that it is always about processes, it was about red tapes and such. Yeah, I do understand why they are there. But my team felt that we can do a lot better, and we managed to convince our general manager then to allow us to have our own walled garden for us to start experimenting with DevOps. That's how we started.
Okay, a walled garden. That sounds like a recipe to start anything. Thanks. That's good. I know that Petronas is on a digital transformation journey. So what was the role of DevOps in that?
When we talk about digital transformation, it's always about how can we use technology to do things better, faster, cheaper, safer, right? And one way to achieve that is by practicing DevOps, using DevOps tools as well as the automation and the shift left methodology so that we can actually do things faster, better, and safer.
Okay, so I'm wondering how challenging was this transformation, especially for a large legacy organization like Petronas?
Yeah, so when we started, it's just us, right? And convincing a small team, especially I was leading the team. It's not an issue. It's always about outside my team. So I would say one of the biggest challenge that I faced previously was the understanding of DevOps itself. The word DevOps. DevOps made of two words, right? Dev, developer, ops, and operations. A lot of people actually thought that DevOps meant combining that developer and operations into a room and somehow the magic of DevOps will happen. No, it's never that simple. I always like to say 3P: product, which is the technology piece, the process, the work processes, as well as the people, people capability aspect of things, right? Now, capability are very important because having a tool does not guarantee that you will be able to use it properly. And that is why in our push of DevOps to the organization currently, the tech is just one small part of it, while we also focuses on processes and the upskilling of the people in order to practice DevOps properly. So that I would say that would be my first challenge then. Now, of course, being Asian, we have very top-down driven organization, top-down driven approaches. So management support, especially top management support, will be very, very important. Without serious top management support, very likely whatever DevOps that we have done will never get past the pilot stage. So in my case, Lisa Chan, which you will talk to later, were very, very helpful in helping me to evangelize DevOps to the senior management, the top management, and actually get them understand the importance of it, as well as invest in this, right? Because DevOps is never free. You change a lot of things, right? So it comes with a cost.
Right. So those are huge challenges that you managed to get over with. You mentioned that you started with a couple of projects in a walled garden, if you will. Where are you now, and what's your vision?
Well, when I started, it's less than 10. That was 1 year ago, roughly 1 year ago. If my memory serves me well, today we should have around 80 to 90 projects in Azure DevOps already. We did that by mostly coaching, providing workshops, telling and showing the project teams how to use Azure DevOps in the practice. Now that is today. Of course, say 1 year from now, I would seriously hope that we can have say 200 applications in Azure DevOps, practicing DevOps. 200 sounds like a big number, isn't it?
Right.
Yeah, so if we were to still onboard applications, by my team, it will be a hard number to achieve. So what we did instead, other than onboarding them, is that we created work processes. We documented them. We put them in our company portal, available to all staff, documenting things like the practices itself, the branching strategy, the pipeline, CI/CD strategy, how do you do test automation, how do you run scrums, etc., etc. So all these things needs to be documented, right? Because we noticed during our onboard of the applications, there are some teams that are actually very interested, I would say, in practicing DevOps themselves. So instead of waiting for my team to onboard them, they try to onboard themselves with our guidance. And such things needs to be properly documented in order for it to have the capability to be organically grown. In long term, it has to be organic. We cannot just depending on one team to onboard everybody onto the practice itself. So having such things documented digitally on a portal, accessible, I believe is very important.
Right, true words. So what are your final advices for our audience who really want to make this transformation happen?
I would say start small. Just like me, try to get a walled garden if you can, in order to minimize the risk, right? And by practicing DevOps, you will stumble and make use a lot of matrices as well as measurement. So this will be the data that you need in order to convince your top management in investing in DevOps. Having said that, it is best if you can get a sponsor among the top management for this particular sponsor to be the evangelist of DevOps to the other top management, right? So that the ball doesn't get dropped.
Right. So start small, get the data, and then have a sponsor who's going to be your evangelist. Thank you so much for joining us, Lok. Valuable words, and I'm sure the audience would love to practice some of what you've said. Thank you.
Thank you for having me, Annie.
Thanks. Bye-bye.
Bye.
Thank you, Annie and Lok, for that scintillating talk show. Hi everybody, my name is Lisa. Today I'll be talking to you a little bit more in depth about how we transformed Petronas in terms of DevOps. So this is what I'll be taking you through today. I'll just give a little bit of introduction about myself and why we embarked on this DevOps journey. It's a fairly recent thing in the greater scheme of how long we've actually been running IT for the Petronas group of companies. I'll talk a little bit about our journey, how we got to where we are, and then I'll leave a little bit of time for reflection on the good and the bad luck that we had, because sometimes in transformation, luck is all you have. You get a certain set of cards that you're dealt, and then you just have to play. So a little bit about me. I'm Lisa, as I said. I lead the digital engineering office in Petronas, which includes DevOps. And my last project was with Petronas IT, where I helped them to put in some of their early transformation initiatives. And after that, they gave me a job offer, which allowed me to break out of my comfort zone and do more or less what I'm doing today, which, as you can see from the lower right-hand corner, it's not very much. This is what I do on a day-to-day basis in relation to the actual work that I actually managed to get done. And I would love to hear from other DevOps practitioners whether this looks like your day as well. And or you can tell me, oh my God, Lisa, please stop talking and do some actual work. But this is what transformation looks like on a day-to-day basis in my company. Getting into why DevOps now, and I noticed that I spent a lot of time talking about why DevOps more than I talk about the how, actually. And even to my own team, I constantly remind them why we're doing this, even to the DevOps gurus within my team and my company, because my perspective is that when you're affecting change and significant change, people aren't spurred into action by facts or what you tell them to do. They do things differently when what you say inspires some kind of emotional connection to their circumstance. And everybody's circumstances are different, right? So when I speak to top leadership, for example, I talk a lot about DevOps in the context of accelerating time to market, minimizing cost leakages, things like that. But when I speak to my own IT colleagues, I talk a lot about creating safe systems of work. And a lot of the time, I show them a picture like this, a day in the life, right? So for anyone who has ever been in IT, you know that it is a thankless job. When things go well, it's pin drop silence. And when things don't go so well, all hell breaks loose, and it's always your fault, one way or another. In IT, no news at the end of the day is really good news. Outages, incidents, sleepless nights, getting interrupted on holiday, these are the kinds of things that IT practitioners can relate to. And I think for a very long time, we were taught, and it was embedded into our psyche almost, that you can only have one choice out of two, which is you can have fast and frequent delivery, or you can have safe and reliable systems. And along came DevOps to tell us that no, actually, you can have both. You can actually have your cake and eat it if you do it well. So that's more or less how I start. Some of you will recognize that I lifted some of these definitions from the excellent book, The DevOps Handbook, by Kim, Humble, Dubois, and Willis. I think it seems very simple when you read these definitions that you wonder why it's even necessary in an organization, because just Google the keyword DevOps and you'll get many definitions, more or less like this. I think that was part of the problem, to be honest, the fame of DevOps. when something is so pervasive in popular media, everyone has a different misconception about it. For example, we had a lot of people who thought that DevOps was just putting a dev guy and an ops guy in the same team, and voila, magically DevOps will just happen. I also get a lot of ideas that DevOps is just the same team delivering new features and handling support tickets. That's a DevOps team in some people's mind. There was also a lot of confusion around whether DevOps was the same thing as Agile Scrum. And there were some people that confused it with design thinking as well, thinking that if you do DevOps, it would guarantee you a product that users would love. But as you know, DevOps practices, they're not a substitution for critical thinking around problem statement definition. So, and all these things taken together, they are part of what makes up DevOps, but they're not on their own. They're isolated and they're not enough to make up a holistic, mature DevOps practice. So that's why we put this definition in place to begin with. Okay, so for the most part, even though it was a struggle at the beginning to bust a lot of myths about DevOps, we finally got people on board with the idea that DevOps was valuable and it is something that we wanted to do for the organization. So I spoke a lot about shifting left, not passing problems further down the line, great stuff like career opportunities, diversification of skill sets, and getting people all excited about safer and reliable systems. So IT thought that this is what we were going to do, but as usual, what our business heard was cheaper, better, faster. And as you know, that's not always the case. Oftentimes, Agile or DevOps transformations are actually slower and a little bit more costly before they get better, more efficient, and faster. So in a way, we were very much the victim of our own early success. In creating that persuasive case for change, I think it created a lot of demand that then put a lot of pressure on us to deliver results as part of this transformation. So just before I share a little bit more about our DevOps journey in detail, I just want to give everybody a sense of what a large IT shop we actually run here. I think it's quite big, but it's all relative. So I love some feedback in the comments about whether or not you think this is large. We support pretty much the entire group, domestically and internationally for Petronas. So I hope these metrics give you a good sense of the size of the estate. Almost 2,000 employees, and at any one time we have about 700 or so projects going. We have lots and lots of tickets, for example, and these tickets are only a subset. They're just the incident tickets. I did not include into this metric tickets to do with service requests, tickets to do with implementation of cybersecurity initiatives, for example. So the total volume that we actually get is a whole lot more than this. Our journey to DevOps. These are just the highlights. If I recall, there was a lot of pain and crying in between those boxes, not even metaphorical crying, actual crying. Our team, we had about 30% internal staff. I have to admit it was very hard, firstly, to take really good performers out of the organization and put them into this team that would just focus on this. So we actually had to hire from outside about 60 to 70% of the team, which actually turned out to be a good thing because we had a blend of people who knew what the challenges were internally. And I just also want to say something about the kind of products that we chose to start small with. We picked apps that were under our control, low criticality, funded by IT, with very little business influence. So this allowed us to control the feature development and the engineering at the same time. And we were able to shield the team from new work coming in, giving them just a small budget and empowering them to select their own tools with freedom from existing practices and internal controls. I remember way back when I gave the team this challenge to put in place DevOps as a POC, and I got the wish list of tools that they wanted to implement within a day. So they'd obviously been thinking about doing this for some time, but they never had the space to do it. So I think in a lot of cases when we think about initiating a DevOps transformation, we have to think about how to give our teams the space to do it without actually having to worry about being prescriptive about what they need to do. Good developers generally know what needs to be done. In the same year, they got all their tools, they onboarded their pilot apps, and we tried to spread the word actually to other applications within my portfolio. But the interesting thing was that we found the precursor actually to introducing these new technical practices was a good understanding of the Agile methodology. Because so much of what we do in DevOps actually comes from the rich history of the lean movement, that, where a strong predictor of quality is short lead times, and short lead times, the predictor of that is small batch sizes. So because Agile methods emphasize that small iterative release where value and detail emerges over time, everyone in our organization was so used to spending weeks, if not months, focusing on big batch development, big batches of requirements, often making sure that you had several hundred pages of requirements before you even started work. So the concept of breaking that down into itty-bitty user stories and small releases and small developments was very alien to most people. And it is still a struggle to a large extent. So we invested first in a lot of Agile training before DevOps onboarding. And very often we made it a prerequisite for the teams to have attended Agile training before we onboarded their applications onto our tooling. In the end, that brings us to today. This year alone, we onboarded 86 products. Our all-time number from the very beginning of time is about 97, so we have 3 more to go before around nice 100. Concurrently, the team is also working on implementing better observability practices through the ELK stack, terraforming, strengthening our security tool chain. So all in all, we're pretty happy, but I think we're half dead from this transformation, and we still have so much more to go. I like to call this my brag stats. Look how far we've come. These metrics obviously aren't a measure of success in themselves. They're just a measure of the degree of DevOps activity and maturity in the organization, for which I am infinitely proud of our teams and the support that we've gotten from our leadership and also the IT community at large. Our partners like Microsoft have also been instrumental and generous in helping us to evangelize these practices within our own company. We did a lighthouse program early in the transformation with Anthony Borton's group. And what he did in those 2 weeks with one of our applications actually went on to define and shape our onboarding program for these 97 products. And like I mentioned, we've done all this, but we're not even halfway done. If I had to guess, we've probably only onboarded about 40% of addressable applications. So we still got some to go. As many of you know, Agile is a business-wide transformation. It's not an IT one. So we struggle with this, and we continue to struggle. Many people think that Agile is just doing things fast or organizing your work plan into sprints, but there is less, but definitely more than there used to be, appreciation for the engineering that goes behind it to make fast, quick, small releases possible. So there is, I believe, a stress and a pressure to deliver products quickly without the proper engineering in place, and that leads to fragile products rather than agile products. Secondly, I have been thinking about empowerment a lot and how it fits in to the DevOps mindset and the success of it. We're obviously a big company. Malaysia's only Fortune 500. And I've been greatly inspired by David Marquette's book on turning the ship around, where he says that control without competence is chaos. And because we are so new in this journey, competence is still something, again, that we are hoping and investing in to continue building. And a lot of DevOps practices actually focus on disseminating controls so that the work and the decisions reside closer to where it is being done, rather than approval sitting away in some distance governance body. So the more and more we implement this, the more and more technical competence becomes really important in what we do. So I think there is a strong correlation between the two, which is why we focus a lot on investing in technical capabilities and also agile certification, so that in the belief and the hope that this actually strengthens our DevOps implementation. Third, we are still separate divisions, dev and operations. In the early days, the DevOps has been largely driven by the development community. More and more, we are seeing the participation of ops in our Scrum ceremonies, and also getting certified, and also working with us on a lot of cloud adoption initiatives. So although I think we are still separate, and this remains a challenge to a true DevOps team, I think we're making some headway on this journey. Lastly, we have so many people to train, and in so many things as well. And this doesn't even include our business counterparts in the Petronas business, the ones that we work with in order to deliver these products, the beneficiaries, our users. So even when we're done with IT, we won't be done, I believe, with the company, because agile education has to extend beyond IT for it to make, and I think, sustain meaningful change in the organization. But I do believe we've had some great luck in terms of, and I did like an informal survey on LinkedIn recently, and most people cited that getting stakeholder and leadership support was the hardest thing that they had to do in order to drive a DevOps transformation. But I got to say that in Petronas, we have had great leadership support. I started this journey with a tiny budget, and now I have a huge budget to implement all the changes that I've been talking about. So support is there. I think understanding is there, and that really clears a lot of barriers for the team, and it's something that I think all of us do appreciate. A supportive partner ecosystem, like I've mentioned, and an interesting last point is that much of this learning and that I've been talking about has not been mandatory. We provide the option for people who want to take these courses, and we open classes for people to register. And we have gotten so much demand that I have had to increase my training budget twice this year to train everybody. So that has exceeded all of our expectations, and to me, this can only mean that people are hungry to change and hungry to learn, and that they can't wait to pivot to the new, so to speak. Please comment with more questions. I'll try to take as many as I can. Thank you for listening, and thank you for your participation.
Hi, Lisa. It was wonderful to hear you speak, and thank you for joining us at the Virtual DevOps Summit.
No worries. Thanks for having me.
So I was listening to you speak, and there were a couple of points that I wanted to hear more about. And one of it was about the shift left part of DevOps. How do you see it, and how challenging is it? And is there some techniques to really shift left?
Well, first of all, I guess it's a continuous process. We're always finding ways to improve the tool chain. We're looking at a few more security products, like I mentioned, to improve this. But I would say that the biggest challenge of shifting left is probably not process oriented or technology related. I think it's very human. Um, I think the persuading independent governing bodies, even within our own organization, to I think let go of the reins or let us run our own scans rather than asking them to run it for us, and then we share the reports collectively as a team, can be, I think, very difficult to accept as well. Um, I I read about Conway's law in DevOps handbook. So when you have two departments, you end up with a process that has two steps. You have three departments, you end up with a process that has three steps. And that's very true in corporate. So when security belongs to another department, as it does in most organizations, I think it's a matter of trust and competency. So very often we do get the request that if we have run a scan, cybersecurity will want it to do it again, just to be sure. So I think it's a journey to make sure that people trust each other and consume the same intelligence and the same reports. So I figure that that's probably the biggest hurdle for me.
Okay. Talking about security, so do you think it's also about the tooling? If cybersecurity is using a different tooling and DevOps team is using a different tooling, is that why there's a need to redo it? Or is it the same tooling and still want to redo that?
Actually, it's the same tooling. So we always try, I think, to be accommodating, and we have to be, because cybersecurity has a mandate to safeguard the organization, right? So they have to remain in control of the tool sets, the configuration, the kind of things that we actually check for, and then finally the decision to go or no go to production. So they have to maintain ownership of that, and maybe over time it's something that can be released if some of that criteria can actually be automated. Yeah, but the point is that even sometimes when it's the same tool, it can be difficult.
Right. It's a journey anyway. So coming to tooling, Lisa, how important has tooling been in your DevOps journey?
Oh, very, very, very important. I mean, I spoke earlier about how agile can be fragile if you don't put in place the correct and adequate engineering in place to actually perform frequent deployments and create those safe systems of work. So Abby, as you know, we're using Azure DevOps as the primary base of our DevOps tool chain. So and I mean, we like the product because it's end to end. You don't have to bundle it much with other third-party products. So we do our source control, we do our CI, we do our CD, everything more or less our testing end to end within the tool chain. And I think this has become even more important now that we're all working remotely. I think maybe we could still get away with it if we were all in the office and developers could see one another. But now we have developers that are offshore, they can't travel here. We have people that are all over the place. We're even doing our cloud migration activities remotely. So the tooling helps a lot. And honestly, without it, I don't know how we would continue to do a lot of the software development activities that we had planned for this year.
Okay, cool. So coming to the human element part of it, one angle is how difficult was it to find the right mindset people? Since I heard you mention that you had to hire in a good part of the team as well.
Well, I think we have to make allowances for the fact that you can never find a perfect team from day one. There is room to grow. right, for everyone. Half the team that we have now in place for DevOps who have become experts in DevOps were not experts 2 years ago, and they have become more so over time. So, and I think it isn't even rocket science. So I don't feel that you have to go out of your way to find the best DevOps talent there is in the market. You have to blend the team with some DevOps experts that have done it before and some people who are willing to learn and understand the mechanics behind it.
Yeah. So how much did things change from your first 10 projects to now 80 odd projects, and when you get to that 300, 400 projects, how do you see this landscape changing for you?
Well, we pay a lot more for licenses now. looking to you for discounts. But when we were just like a 5 application shop, and we were managing the tool chain, obviously we could do whatever we want. But now that we have scaled to 80 products and we support the tool chain for products that are not owned by our development teams, that are immediately under me, they are under different people in Group Digital in Petronas. So I think that stewardship means that we have to create guidelines on what you can, what you can't do, our branching strategy, what is in CI and which development frameworks to use and which type of CI to use. So all this needs to be documented, all this needs to be rolled out, and teams need to be onboarded on the basis of what kind of application they're managing. So codifying all of that was a challenge for us because, developers, they just like to build things and like break things and do things. They don't like to write. So I think that codifying that and making it a standard and making it easy, accessible for everybody to understand and onboard themselves was how we scaled it. And we worked with a partner for this, and we worked with Microsoft on this as well.
Right. Great. And you mentioned something a little bit back about there's more to actually digital transformation through DevOps than just the tooling and stuff. Talk to us a little bit more about that.
Well, we spoke a little bit about, I think, the importance of leadership support. And I continue to be humbled by my team and how much more they know compared to me. Early on, when we had just started to put the team together, and I had a very cursory understanding of Agile. I was one of those, ajaran sesat people that didn't really understand the fundamentals of it. So I was very hard and very demanding on the team. I thought that I could change the scope at any time. I thought I could interrupt them mid-sprint and include in a requirement in the backlog because the product owner asked for it and the product owner was my boss. So I came into a lot of pressure when I should have been protecting the team. And we had a number of fights, me and Loke's boss had some fights about this in the early days. And I think it was only after a few rounds and after I had committed to Agile training myself did I understand what I could and could not demand from the team, how things worked. So I think the point is that we ask for leadership support, but at the same time, I think leaders have a responsibility also to understand how their teams work and to respect that. And another example is I should have been the one to attend the Scrum ceremonies, but I asked the team to organize separate meetings with me or to send me updates instead, when I should have been going into Confluence to read the updates for myself and pull the information for myself. So I think those soft skills and the dynamics around how you interact with your staff are very different in the Agile DevOps world compared to what a lot of us are used to in corporate.
Right. So what's next for DevOps, if you will, when you think of it from a business head standpoint or digital transformation standpoint?
Well, I want us always to be improving our practices. So I want us to keep doing that, finding new ways of doing existing things and doing it better. And that's why I think events like this are important. You know, we get out there, people ask questions, we find out what each other, what we're doing. I also want to pay more, now that we have the tooling mostly in place, at least the basic tooling, I want to pay more attention to psychological safety. I think people need to speak up more, people need to give feedback, people need to be open to that feedback, people have to conduct useful root cause analyses, and people have just not to get out of the witch hunt mindset. I think whenever there's an incident or an outage, that's something that we need to improve on.
And now we're moving to the last part of it. It's lovely to hear that you have a book club going. What's a book you would recommend for the audience?
Well, I mentioned the Devops Handbook quite a lot in this presentation, and I also like to read the precursor to that, which is the Phoenix Project for inspiration. So, you know, one's kind of like fictional and one's non-fictional. And I also mentioned David Marquette's book, Turn the Ship Around. So these are the three that I would recommend for anyone. I mean, everybody's got their favorite books, but these are mine.
Wonderful. I'm surely going to pick them up and read them.
Yeah, look at all these like post-its and everything. These are my Bibles, you know.
Yes. And hopefully finish it before 3 months.
Yes.
Okay. So thank you so much for joining us, Lisa. It's always a pleasure talking to you. I learn a lot just by talking to you as well. I'm sure the audience has loved this segment with Petronas, with Lok, and with you, Lisa. Thank you.
No worries. Happy to be a part of this. Thanks for inviting us, Annie.
Hello, everyone, and thank you for joining me for the Getting Started with Infrastructure as Code using Terraform session. My name is Zachary Deptawa, and I'm a cloud advocate at Microsoft. We'll start off by covering what DevOps is and what makes it such a powerful experience. We'll talk about source control with a quick introduction to Git and GitHub. We'll then talk about what Infrastructure as Code, or IAC, is, and we'll finish up by looking at how you can get started with Terraform. Before we go into what Infrastructure as Code is and why it's awesome, we need to take a quick look at what DevOps is. I love this quote, and I think Donovan hits all the major points of DevOps here. DevOps is the union of people, process, and products to enable continuous delivery of value to your end users. DevOps is about bringing people together through shared common goals, increased collaboration, and a focus on improvement. Now, technology plays a key role in helping to execute a DevOps strategy by enabling teams to collaborate more efficiently, enhance their productivity, facilitate experimentation, and automate their processes from development through to delivery and even operations. This is where Infrastructure as Code comes in. What this all boils down to is the ability to deliver value faster by increasing efficiency, eliminating waste, and streamlining the feedback loop for developers and operations to continuously improve their products. The result? Better products delivered faster to happier customers. And when you think of products, you might be saying to yourself, but Zach, I'm an operations engineer. I don't build products for end users. But think about it this way. When you stand up infrastructure for other teams within your organization or company, those teams are your customers, even though they're internal. Making the process to stand up and maintain infrastructure more reliable and efficient will help every part of your organization, and that ripple will be felt all the way down to product delivery to your end users. Now, the people portion of DevOps is the toughest change to make. And that's because it's a cultural shift that needs to take place. Everyone within an organization, from the top down, must become hyper-focused on continuously delivering value for a DevOps strategy to work effectively. For the process, it needs to allow for fast innovation, yet still deliver code of high quality. So what does that mean? We need to be able to plan sprints. Our team needs to be able to check code in and out of a centralized location while tracking changes made by other team members. As they're checking code in and out, builds need to kick off. Automated testing needs to run. Security scans need to happen. If the builds are good, an automated system needs to pick up all the bits and deploy them for us into dev, QA, UAT, all the way out into a production environment. I keep mentioning automation, but it's super important. Potentially, this can happen many times a day. We need to make sure the process is consistent and repeatable every single time. And once the code has stood up our production app, it doesn't end there. We still need to be able to monitor that code in production. We need to know things like, is the app up or down? Is the app performing well? And what are users really doing in the app? Answers to those questions will let us know if we're delivering value to our end users. If we are, we can double down on those types of activities in the next sprint. If not, we can quickly reprioritize our backlog and course correct. So we just talked about the ability to check code in and out of a central place to help us track changes across our organization. But what tools do we need for that? That's where source control comes in. What is source control and why do we need it? Well, source control is a form of version control, and it uses the concept of centralized code repositories to track changes on all the artifacts within those repositories. By its very nature, it enables cross-team collaboration through things like branches, versioning, and commit history. One protocol for source control is called Git, and arguably the most well-known Git repository hosting provider is GitHub. A Git repository at its core is just a collection of files and folders that comprise a product or application. Some common things you'll find in a Git repository are things like the actual source code for that project, a .gitignore file that allows you to tell Git to ignore files that you aren't currently tracking that match certain expressions within that gitignore file, branches that allow you to isolate development work from your main or production code, This allows developers and engineers to work on things in isolated areas without affecting a live code base. And changes made within these branches can be merged back into the main branch as work gets completed and reviewed by your team. It includes commits that track changes to the artifacts within that repository, so you can better understand what changed, when it changed, who changed it, and why it was changed. And tags, which point to a specific release of your codebase. Now let's talk a little bit about GitHub. GitHub is the leader in Git repository hosting. Some of the features that make GitHub so popular include the ability to track things like issues, bugs, and features across your projects, the ability to more easily share expertise by encouraging comments and communication at various steps of code writing, and the ability to easily set up a myriad of integrations with other services such as Microsoft Azure. You've even got the ability to do work inside a hosted, instant, fully featured dev environment through code spaces on GitHub without ever having to leave your browser. One of the most powerful features of GitHub is GitHub Actions. This allows teams to automate their workflows with world-class continuous integration and continuous delivery, or CI/CD. What this means for your organization is you won't have to worry about manually kicking off testing to validate that your code changes are ready to deploy. With a little setup, GitHub Actions can handle that and make sure your code is bundled up and ready to deploy as engineers submit pull requests for their projects. What this means for operations engineers is a more streamlined process for delivery of your infrastructure changes, less time spent on mundane tasks, and more time spent doing what you do best, writing code to manage your projects and infrastructure. So what are some of the things you might find in a GitHub project that you won't find in a standard Git repository? Things like a README Markdown file that allows teams to better document the project within that repository, a security Markdown file that allows teams to define their security policy, a license file that defines the license for the project, a code owners file that allows teams to define who is responsible for what parts of that code base, pull requests that allow you to request to merge a set of changes that exist in one branch into another branch. This feature is cool because it also allows teams to double-check work and communicate changes before they're ever merged into your code base. So now that we've gone through what DevOps is at a high level and how source control fits into that puzzle, let's talk about infrastructure as code. This is a quote from Sam Guckenheimer that I pulled from Microsoft Docs, and I think it's a great description of what infrastructure as code is. Infrastructure as code, or IAC, is the management of infrastructure, networks, virtual machines, load balancers, and connection topology in a descriptive model using the same versioning as a DevOps team uses for source code. The main point here is that we're actually defining and managing infrastructure with code, much like a developer would manage an application they're building with code. Being we're defining our infrastructure much in the same way we'd be writing source code for an app, we can lean on things like source control via GitHub to collaborate across our organization and to keep track of any changes requested or made. So let's take a step back. I started working with hosted environments and infrastructure back in 2005, and at that time, dedicated hosting was all the rage. Virtualization and cloud were just starting to become popular, but they weren't as widely adopted just yet. What that meant for me as an operations engineer, needing to provision new environments was a request to our data center team with an order for cabinets, switches, and servers. The data center engineers would then physically stand these cabinets up, build the servers, and wire it all together. That process could literally take weeks depending on what was needed, even if we had that gear in stock. We lived in a world that was slow changing, so our work consisted of administrating these servers daily. If something needed to change on these servers, we'd use our terminal to SSH in and take care of that work. Requesting new servers to replace the old ones was expensive, slow, and painful, and it didn't make any sense for us at the time. Fast forward to today, and we have the ability to nearly instantly stand up servers with the click of a button or a few keystrokes on the command line. Gone are the days of waiting weeks to stand up infrastructure for the holiday shopping surge, just to tear it all back down again after the new year. We now have the ability to stand up and tear down entire environments multiple times a day if needed, and that's amazing. But we need a way to easily manage it, or it can get out of hand rather quickly. Let's take a look at this example. What you see here is an illustration of a simple web app. a web server behind a load balancer, and a database. We could head over to the Azure portal and spin this all up manually within a few clicks. And then we could log into these servers to install the services needed to render and serve our web traffic. We could then manually copy all our files up to the web server in the document root so they can be read by the web service. We could manually open up appropriate ports that are needed through our portal. Everything would be working just fine. When we talk about managing infrastructure in a traditional sense, this is the way it's been done since hosted infrastructure was a thing. It works, but where's the documentation? If you have one or two people working on this infrastructure and something goes wrong and you can't reach those engineers for whatever reason, is there any way to know for sure how it's set up without any kind of documentation or time invested troubleshooting? What if you lost all connectivity to this environment? Assuming documentation didn't exist, how quickly could you spin it all back up in a different region or data center and have it in the same state as when you lost that connectivity? How quickly could you spin up and configure a dev environment identical to this one for a dev team that needs to work on a major or emergency-related change? These are some of the things that infrastructure as code can help solve. With infrastructure as code, you define your infrastructure, your servers, your network, your application topography, and you store it as code in much the same way developers store application source code. Let's take the previous example app, for instance. Instead of building this environment through the portal, we can define our application in a text file using a standard text editor. In this text file, we can define the things that we need for our infrastructure at that moment. We declare what we want. There should be a load balancer. There should be a web server. There should be a database. We don't have to write any confusing if statements or while loops. We simply declare what should exist. But we're using text files, much like standard source code for applications, so we can benefit from things that make a DevOps solution such a powerful place to be. Things like source control and automation. Say we need to add another web server to this example app. Being we're using source control via GitHub, we can easily create a new branch, make the changes necessary to the code in that branch to add another server, notate why the change was made, and request to merge our changes back into the main or production branch of our repository through a pull request. If we've got GitHub Actions configured, we can even have these changes propagated automatically on an accepted pull request. The best part is we've defined what our infrastructure looks like as we've written this code. We have documented it, and better yet, we can use this documentation to rapidly spin up and spin down entire environments that look exactly like the one that we created. We've also got a mechanism to track changes made to our environment, so we no longer have to guess who requested or made a change or why they made that change. So this is all great, but we can't just jot down what our infrastructure would look like in a text file. We need a tool that can understand what we're defining and that can reach out via APIs to our infrastructure providers to manage this infrastructure topology for us. That's where Terraform comes in. Terraform is an open source tool made by HashiCorp that allows you to build, change, and version infrastructure. The infrastructure Terraform can manage includes low-level components, such as compute instances, storage, and networking, as well as high-level components, such as DNS entries and software as a service features. It allows you to define your infrastructure and application topology in configuration files using the HCL or HashiCorp configuration language syntax. These template-based configuration files allow you to define, provision, and configure Azure resources in a reliable, repeatable, predictable manner. Terraform is cloud agnostic and uses a provider and resource model. What this means is Terraform is adept at deploying an infrastructure across multiple cloud providers, and it enables developers and operations engineers to use consistent tooling to manage every single infrastructure provider their topology spans. A Terraform provider is what understands and handles API interactions that are required to make changes to your infrastructure, be it a cloud provider like Azure or even a custom provider that you've written for proprietary in-house infrastructure. When you create a Terraform configuration file, you specify what provider you're working with in regard to the resources you'll be managing. To work with Azure resources, you'd specify the Azure RM provider, for example. Providers can also include things like Kubernetes, and you can have several providers in a single code base, One example of that would be using the Azure RM provider to stand up an Azure Kubernetes service cluster, and the Kubernetes provider to deploy pods and services into that cluster. And as I said, that can happen all within the same code base. Resources are really the most important aspect to Terraform. Each resource block defines one or more infrastructure objects, such as virtual networks, compute instances, or higher-level components such as DNS. In this example, our resource block declares a resource of a given type Azure RM _ virtual _ network with a given local name of tfdemo _ network. Because of Terraform's syntax interpolation, we can use the name tfdemo _ network to refer to this resource from other parts of the Terraform configuration. You can see an example of that syntax interpolation on lines 24 and 25, where Terraform will be grabbing and reusing the location and name of the resource group named tfdemo _ resource _ group. Most arguments within each resource block are specific to the resource type we're working with and are not universal across resource types. For instance, you would want to set an address space when creating a resource of type virtual network, but you would not set an address space for a resource of type managed disk because that's not an appropriate argument when creating a managed disk. It's super important to check out the documentation for each provider and resource you're managing to ensure you're using the proper arguments for your resource type and provider. You can find Terraform's documentation at terraform.io/docs. When you apply changes, Terraform will inspect the working code base and form a dependency graph of all your resources. If you're applying changes to an infrastructure you already manage with Terraform and a state is currently tracked, it will look at where your state is currently and will form the dependency graph based on what changes are needed to your current infrastructure state to get to the state that you want to be in according to your current run. This dependency graph allows Terraform to run tasks in parallel for the creation and modification of any non-dependent resources. Because of this, Terraform builds infrastructure as efficiently as possible, and operations folks can get an insight into dependencies within their infrastructure. What this means is Terraform will intelligently build or manage resources simultaneously where no dependency exists, but will ensure proper build order where a dependency does exist from one resource to another. For example, if I'm setting up a new resource group and a web server to be deployed in that same resource group within my configuration, Terraform knows we can't create the web server until the resource group exists, so it will build them in the appropriate order with that dependency in mind. I mentioned Terraform is cloud agnostic earlier, and this means you can work with over 70 different providers that currently exist in Terraform today, and that number is growing as provider support expands. If you run a proprietary architecture that has API access, you can also write your own provider if one does not exist for it currently. One of the most powerful parts of Terraform being cloud agnostic is the HashiCorp configuration language syntax does not change from provider to provider. It's true, you'll have to use different resource blocks that are specific to each provider, but you won't have to relearn how to interact with that provider. Right now, if your infrastructure spans multiple clouds, it's likely that you have to learn how to navigate several completely different portal experiences. If you're using API command line tools, you're having to use different syntax to speak to each different provider. With Terraform, there's one syntax. To use your Terraform configuration with any of your providers, you won't ever have to deviate from a Terraform init to initialize your working directory and pull down any provider plugins and modules necessary for that code base. A Terraform plan to inspect your current state and working code base to build that dependency graph we just spoke about and to show you what changes are about to be made. And a Terraform apply to actually apply those changes if all looks well. The same commands to manage your infrastructure across any provider is a beautiful and powerful thing. All right, so let's take a look at what it means to run infrastructure as code. Let's start in GitHub. This is the tfdemo app, and this is the app that I'm going to be using for the purposes of this demo. As you can see, I'm in the main or production branch. I only have one branch in this repository. These are the files inside of my repository. This is the readme.md file. This is basically where I document what this code base does and how to use it. Also some links for more information there. And if you take a look at the top here, there's an Issues tab. This is where you could track issues like bugs, feature requests, things of that nature. You can also see a Pull Request tab here. This is where you could view open pull requests or create a new pull request to merge changes from one branch into another branch. And this is the Actions tab. This is where GitHub Actions can be configured. This is for the workflow automation portion, the CI/CD, or continuous integration and continuous delivery. We're not going to go into this for the purposes of this demo, but this is where you would find that. And you can see there's other tabs at the top like Projects, Wiki. There's a Security tab where you can set up security policies and view things of that nature. There's also an Insights where you can get insights into your repository. And there's also a number of settings that you can change for your repository, but we're not going to get into that today. Let's go back to the code base. For the purposes of this demo, I've already cloned this repository down locally, but if I hadn't, I could click on this code tab, copy this URL, and run a git clone to pull it down locally on my machine. If we take a look at my Azure portal, I have a dashboard for everything that's tagged with the environment demo, and as you can see, that's currently empty. There's no resources to display. All right, so let's switch over to VS Code and take a look at the code base on my machine. So as you can see, we're inside of my local repository. You can see all of the same files locally that I had inside my repository. I just have them cloned locally. You can see also in my terminal here that I'm in the main branch or the production branch of this repository. And if we take a look at the readme.md file, this is the same readme.md file that was on my external repository hosted on GitHub. But it's got a lot of great information, and what I want to point out is you have to set up your authentication here. You have to use client ID, client secret, tenant ID, and subscription ID. And you don't want to store those inside of your code base because that's a security risk. What I do for the purposes of my demos is I export these before the demo as environment variables. So you won't ever see me set these, but they're already set as environment variables, and that's what Terraform is going to be using. All right, so let's take a look at the main.tf file. And .tf is just the extension for my Terraform configuration files here. As you can see, I've got a lot of good comments just so people can see what's going on in these files if they're browsing them. So let's step through this. The first thing we want to do is set up our provider. And our provider is Azure RM because we're going to be deploying resources to Microsoft Azure. We're also creating a resource group. We're using the Azure RM resource group resource, and we're calling it TF Demo Resource Group. The location is West US 2. We're going to set some tags for environment and build, and those are just tags for my own purposes here. You'll notice that I'm going to be using syntax interpolation throughout this file to call back to the location and resource group name from that resource group that we're creating. Instead of copying and pasting that information, I'm using syntax interpolation. And that's awesome because that means if I make a change to this resource group, say to build another one of these in like East US or East US 2, it's going to use syntax interpolation throughout this file to make that change. I won't have to change it in more than one place. There's not a ton of things copied and pasted throughout this file because of that syntax interpolation. It's very powerful. Also, if we're building anything inside of this file that we need to refer to and say the ID is unknown until that resource gets built, you can still use syntax interpolation and Terraform will propagate that ID or that information that is not yet known after the resource is built for you. And this goes back to the dependency graph conversation that we were having earlier. But you can see as we continue, we're creating a public subnet that's going into that virtual network using syntax interpolation again there to specify that virtual network's name. We're also going to create a private subnet. And again, we're using syntax interpolation here. And you can see that we have the network set as well. We have to create a security group to allow the public subnet on port 80. And so this is basically allowing inbound traffic to port 80 on our web server. And this is so our web server can serve traffic via HTTP for the purposes of this demo. We're also going to associate the security group with the public subnet. And that's because that security group for port 80 should only apply to the public subnet. And that should allow that port 80 traffic inbound. And you can still see all the syntax interpolation throughout this file. We also have to create a network interface for the server. And you can see that we are allocating a dynamic IP address and that the subnet ID is that of the public subnet ID. And we don't have that ID yet because it's not created yet, but we're using syntax interpolation, so we're totally fine. Continuing along, we're creating a public IP for the load balancer to be assigned to the load balancer. You can see that it's a static IP we're creating. When we create the load balancer next here, you'll see that the front-end IP configuration actually calls back through that syntax interpolation again to that public IP that we just asked to create. So next here, we are creating a back-end pool for the load balancer. This is a pool that we're going to stick the network interface for these web servers, or this web server, into that load balancer back-end pool, and that's so that load balancer can send traffic to this web server. We also have to create a health probe on port 80. This is to make sure that we are sending traffic to healthy web servers and not web servers that are not listening on port 80. We're also going to create a load balancer port 80 rule. This is going to send TCP traffic from port 80 to port 80 on these servers. And you can see that we are sending that to the backend pool that we just created, as well as using the health probe for port 80 that we just created. We're also creating an availability set for the VMs so that any VMs that we put behind this load balancer can be in that same availability set. And here's where we start creating things for the web server. We're going to create the disk for the web server. And we're also going to issue the create for the actual web server itself. And you can see that we're using the Azure RM Virtual Machine resource block. We're going to name it tfdemo_web01, and you can see all of the syntax interpolation again that's being used to create this server. You can see the availability set that we are using syntax interpolation for as well. You can see this is going to be an Ubuntu server, 1604 LTS, and this is all of the storage and data disk information for this server. You can see that we're setting OS profile information as well. And again, we are also setting those tags. And as we get to the bottom of this file, we'll see that we're using the Azure RM Virtual Machine extension. And what this does is it runs a post-provisioning step on this server to run some commands that I have. So if you see below here in the settings block, there's a command to execute. And what's being executed is an apt-get update, an install of Nginx, and I'm going to echo tfdemo-web01 into this docroots index.html. That way the server responds with that when I hit it on port 80. So now that we've taken a quick look at what this main.tf file holds, let's go ahead and look at Terraform. So I have the Terraform binary installed. It's just a binary, just a single file. And I can run a Terraform init, and what this is doing is it's initializing this directory for me. It's taking a look at my code base and it's pulling down any provider plugins that are needed. You can see that it did pull down the Azure RM provider. And you can also see that Terraform has been successfully initialized. So if we take a look at our files here, there's a .terraform folder, and that folder is holding that information that was just pulled down. So we've run the Terraform init. Let's run Terraform plan. And what this is doing is it's looking at our current state, which is nothing. We don't have a previous state yet. And it's saying, what is it going to take to get to where we need to be for this declaration that you've just made in this main.tf file? And you can see all of the things that's going to change here. Everything that's going to be created is denoted by a plus sign, the green plus sign that you see there. And of course, we don't have anything to change, so everything here is going to be a create. And you can see it's creating everything that we just went through in this main.tf file. And again, this is just the plan output. We haven't actually made this change yet. This is just showing us what will happen if we run an apply. You can also see that some of this information won't be known until after an apply because these things don't exist yet. And that's why that syntax interpolation is really, really handy. So we've run the Terraform plan. Now let's go ahead and apply these 17 changes. I'm going to run a Terraform apply now. And this is actually going to rerun the plan. It's going to show me that output one more time, and it's going to ask me to confirm, and I have to type YES, yes, to confirm these changes. And of course, these are all the same changes that we just looked at, so I'm going to type yes. And now that I've hit enter, it's going to start actually making these changes. It's actually going to be calling out to the API of Azure to make all of the changes that I've just requested. And now that everything is completed, you can see that 17 resources were added. 0 were changed and 0 were destroyed because we were just creating things and nothing was being changed. If I run another Terraform plan, you're going to see that there's nothing to be changed, nothing to be created, nothing to be destroyed, because we just ran this code and we have not changed anything about our code base. Terraform knows there's nothing to be changed because it's actually tracking our state in the terraform.tf state file there on the left. And now back in the browser, when we refresh, you'll see that everything has been built. Everything's showing up under my environment tag of demo. And now if I look at the load balancer and I copy the IP address, let's go ahead and open that in a new tab. And you'll see that my load balancer is actually sending traffic to my tfdemo-web01 server. So everything worked as it should have, and I'm able to hit this server. But what if we want to change this environment? Let's take a look at this web02.tf.off file. This is actually just a TF file, a Terraform configuration file, that I've labeled .off so Terraform would not pick it up when we first ran the first run here. But what this is doing is it's just building a Web02 server, just like the Web01 server, except it's going to respond with TF-Web02 on port 80. So let's go back over to my web browser. We're going to create a new branch to do some work. We're going to add a Web2 server, so let's call it add Web2. You can see the new branch was created. Let's go back to VS Code, and I'm going to do a git pull here. And I'm running a git pull to pull that new branch information down to my local repository from my remote GitHub repository. You can see that it sees that new branch now. So let's git check out add-web2, which is that new branch. You can see I'm in the new branch. So I can do all of my work in this branch. So let's go ahead and rename this file to just .tf. We'll remove that .off. You can see that it's now recognized as a Terraform configuration file. So now that we have this new code to create another web server, let's do a Terraform plan and see what it says. So it's looking at my current state, which says that I have a load balancer, I have a network, I have a resource group, I have a current web server, but I don't have a Web02 server. So it's going to respond and say, let's add the things to build that Web02 server. And these are all the things that are required to add that Web02 server per that new .tf file that I created. You can see there's 5 things that it's going to add. 0 are going to change and 0 are going to be destroyed. So let's do a Terraform apply and get these changes in. And just like before, we're going to see that it's going to run another Terraform plan for me and show me that output, and it's going to ask me to confirm with a yes to make sure I want to make this change. And yes, I do. So let's go ahead and confirm it. And now that we've confirmed, it's going to build that Web02 server for us. It's going to add it to the availability set, and it's going to put it in that load balancer's rotation. All right, we can see that the apply is complete. There were 5 resources that were added, 0 changed, 0 destroyed. So let's go check out the browser. If we take a look at our resources now, if I run a refresh, we're going to see that Web02 server now exists. And there it is. Let's take a look at the availability set. And we'll see that that Web01 and Web02 server are both running in that availability set. Let's go over to the tab where we have our load balancer IP. If we refresh, we can see that it's jumping now between Web01 and Web02. So this is perfect. This is exactly what we wanted to see. So let's go ahead and use VS Code to commit these changes and push them back into our Git repository. We want to have these changes committed into our repository so we can keep track of what's going on. You can see I've renamed this file. Let's go ahead and stage these changes. I'm going to add a commit message saying that we are adding Web02. Let's go ahead and commit this, and we're going to push the changes to our branch, the add-web2 branch. You can see that the changes are being pushed up right now, and that's all done. I can also go into the terminal here inside of VS Code and just do a git status just to make sure that everything's pushed up and you can see everything is up to date. If I head back to GitHub in the browser, you can see that add-web2 had recent pushes less than a minute ago. So let's compare and create a pull request. So this pull request is going to request to merge my changes from my branch that I just did work in into the main branch. You can see that it's coming from add-web2 to the base main or production branch of this repository. So I'm going to add a message here for the pull request, just saying I added a Web02 server. I'm going to go ahead and create that pull request now. Once that pull request is created, you're going to see it's going to check for the ability to merge automatically. If continuous integration had been set up, it would kick off now. And you can see my changes here. All I did was rename the web02.tf.off file to web02.tf. And I can actually go into the commits. If I wanted to, I could click on this commit specifically and see exactly what that commit held. You can see it was just that rename, so there's not much to show here. Let's head back over to the conversation tab. And I'm going to go ahead and say, looks good to me, and I'm going to comment, and I'm going to merge this pull request. If this were a real pull request, you would want someone else to review the pull request for you. But being this is just a demo, I'm going to go ahead and confirm the merge myself. You can see that the pull request successfully merged now. If I go back to the code area, you can see that web02.tf is no longer named web02.tf.off. If I do a git checkout main here and I do a git pull, you'll see that my changes are updated and that my merge was completed. If I go back to the files here, you'll see web02 is now .tf in that main branch. And if we run a Terraform plan now that everything has merged back into the main branch, we'll see that it's going to check the state and it's going to say there are no changes that are required because nothing has changed in this code base since the last run was applied. And so that's exactly what we want to see. No changes, infrastructure is up to date. I also want to mention that inside of VS Code, there's an extension marketplace. And you can see that there are Terraform extensions here, HashiCorp Terraform and also an Azure Terraform. And that's what's showing me all of this awesome syntax highlighting and giving me all of this great IntelliSense as I've written this code. It's great stuff. If you're going to be working with Terraform, I highly recommend that you check it out. And if you want to tear down all of your infrastructure that's being managed by Terraform, you can run a Terraform destroy. And like the command says, this is a destructive command. So what it's going to do is it's going to kind of run a reverse plan for you. It's going to tell you, here are all the things you're about to destroy, and you have to confirm with a yes that you want to destroy them. You'll see everything is in red here. There's minuses. There's marks here to show you that everything is going to be destroyed. And you can see that it's all in bold red. It's going to destroy 22 items. I'm going to go ahead and type yes. And you'll see that it's going to kick off the destroy and remove everything for me. And now that it's completed destroying 22 resources, if I head to my browser and go back to my demo dashboard, you'll notice that everything is gone. It's cleaned everything up for me. We've covered a lot today, so let's recap. We talked about what DevOps is at a high level. We looked at what source control is with a quick intro to Git and GitHub. We discussed what infrastructure as code is and its benefits. And we looked at an intro to using HashiCorp Terraform to manage infrastructure. If you'd like to take a deeper look into what DevOps is with overviews, tutorials, samples, and more, head over to aka.ms/DevOps-APAC-Learn, where you'll find our DevOps Resource Center. You can also check out aka.ms/DevOps-APAC-TF to learn more about using Terraform on Microsoft Azure. Thank you for joining me, and have a great day.
Hi, good morning, good afternoon. My name is Tamarai and I'm the Azure Applications Lead for APAC. I'm here to give an introduction on how security works with Kubernetes workloads and how various Azure security features work seamlessly. Following my introduction, we will have Vivek Ramachandran of Pentester Academy providing top 10 tips to enhance your cloud container security. As the adoption of Kubernetes, or K8s as they are popularly called, along with DevOps, continues to expand, security is top of the mind for many. Since K8s are used to run applications on a large scale, and they control who and what can be done with these applications, security should be well understood and managed. Azure Kubernetes Service, or AKS as we call it, is actually a managed service from Microsoft Azure and based on Kubernetes open source for scalable container workloads. DevOps provides great agility on Kubernetes and container workloads as well as enhancing security. Let's actually dig into how security is enforced with DevOps, AKS, and actually the other Azure security features, how they all come together. Let us look at some Kubernetes security essentials first, right? So let's start with securing the software supply chain. This actually starts with vulnerability scanning and compliance checks, like many of you will be doing. So when it comes to image vulnerability scanning, we have Azure Container Registry, which is scanned by Azure Security Center. And governed by Azure Security Center, the Azure Container Registry only deploys validated images. So when the image fails the vulnerability scanning, Azure Security Center provides actionable recommendations to help you mitigate the risks. And now let's look at the compliance check area. With Azure and DevOps, we have something called as Azure pipelines, which are governed by Azure policy, which helps in dynamically enforcing guardrails with the policy definitions at the time of deployment or as part of your CI/CD workflows. We can also auto-build with audit, enforce predetermined best practices policies very easily, and we can actually deliver with continuous security. As well as with K8s and DevOps, there are other security essentials regarding Kubernetes and containers which you need to consider, and let's take a look at them. So let's see what kind of hardened security can you get for your Kubernetes resources. Firstly, let's look at authorization and authentication. You can actually use familiar tools like Azure Active Directory for fine-grained identity and access control to Kubernetes resources from clusters to containers. So Active Directory, role-based access control, pod identity using Azure Active Directory, all of this is possible in the container context. What about pod security and privilege configuration? You can consistently enforce pod security context and configurations across multiple clusters with Azure policy. You can actually get compliance reports for the entire environment with pod level granularity also. Next, you can actually easily investigate suspicious API requests, collect statistics, and create monitoring alerts. All of these come as part of Azure Kubernetes Service. API audit logging is actually part of AKS, and you can achieve API traffic audits. Finally, with Azure Key Vault, you can actually do secrets management and achieve Kubernetes secrets protection. You might ask, what about protecting your nodes and workloads in the container context? let's actually start with encryption of persistent volumes. When it comes to encryption of persistent volumes, we have, again, Azure Key Vault. It helps in encrypting disks using your own Azure keys. What about operating system security? You can get hardened OS images with automatic OS patching. You get security with the default operating system from AKS. And with regards to threat protection, again, Azure Security Center is your answer. You get automated threat detection and best practices recommendation for Kubernetes clusters and nodes using advanced analytics from Azure Security Center. So you might ask, what about data security? So you can get advanced data security with managed databases on Azure. Managed databases meet the most stringent compliance standards with built-in auditing and information protection technology. So it secures your data by encrypting data in motion with transport layer security. So that picture actually concludes our section on securing your nodes and workloads. So moving on now onto our last section, which is on network segmentation, which is important. So firstly, with respect to pod-to-pod communication paths, network policy, what can it do for you is you can secure pod-to-pod communication path. You can actually secure communication paths between namespaces and nodes, and to get better controls with user-defined network policy. Next, getting access to the Kubernetes API with Azure Private Link. You can isolate your master node from the internet. Azure Private Link completely isolates your workload from the internet and limits access to the Kubernetes API server to your Azure Virtual Network. Next, let's look into the workload isolation piece. You can limit workload exposure with Azure Virtual Network and network security, network security groups actually. Azure Virtual Network and network security groups enable private connectivity between Azure Kubernetes Service and other services like a container registry. You can also limit public endpoint access to reduce unauthorized access risks. Moving on, the correct way to ensure threat and intrusion protection is actually with the help of application gateway with the web application firewall. It protects your workload from common exploits. The Azure Web Application Firewall, or WAF as we call it, on Azure Application Gateway provides centralized protection of your web applications from vulnerabilities and other exploits. Azure Application Gateway also serves as the ingress traffic load balancer for Kubernetes pods within an AKS cluster. Next, while looking at outbound traffic restriction, one can restrict with the egress lockdown from Azure Kubernetes Service. You can actually prevent malicious activities from originating from the cluster using egress lockdown and restrict egress traffic for cluster nodes to a limited number of ports. You can also deny access to harmful resources outside of the network. Finally, to wrap up, while looking at cross-environment connections, you can ensure private connection between Azure and on-premises systems using Azure ExpressRoute. Azure ExpressRoute creates private connections between Azure data centers and on-premises systems and offers more reliability, faster speeds, and lower latencies. I hope all of you got a good idea about managed Kubernetes services with Azure Kubernetes Service and how various Azure services provide comprehensive security along with DevOps for your clusters, Kubernetes clusters. So with that, I welcome Vivek Ramachandran of Pentester Academy to talk about the top 10 security tips for cloud containers. Thank you.
Hello, everyone. My name is Vivek Ramachandran, and today I'm going to be talking about the top 10 tips to enhance your cloud container security. So as we all know, containers are the lifeblood of the cloud, and pretty much all of us deploy it. But what we kind of find is not all container deployments are secure, by default. And this is really where we want to kind of make sure that you understand these top 10 tips and try to follow them. So a little bit about myself before I begin. My name is Vivek. I've been working in cybersecurity for close to 2 decades. I've worked as a researcher. I found first in world attacks. I've been featured in the media. I won multiple competitions, and I've traveled the world, speaking at top security conferences like DEF CON and Black Hat. I've authored multiple books on cybersecurity, which you can find on Amazon and purchase. And I also am the founder CEO of Pen Tester Academy, which is one of the topmost places in the world for enterprises to learn cybersecurity. Now, what we've done is a lot of these demos that we have, you can even try out for free, and you can just go to attackdefense.com and try them out. So let's begin. So before we get started, let's try and understand some basics about Docker. Now, Docker is one of the more popular container management, tools out there. So we'll focus on that, even though the same discussion applies to others as well. So I think Docker created a massive revolution by making containers easy to use, manage, and deploy. Right? Containers themselves were an abstract which were there in the Linux kernel for a very long time, but Docker made it approachable. So what are containers and how are they useful? Well, very simply, what we want is for a package of an application to be deployed anywhere, but in the same consistent way. And this is really where Docker or other container technologies allow us to do this in a very predictable fashion. Now, the idea really is that all the dependencies and everything is kind of packaged into that container, and that it can be deployed at scale. And then management tools are available to go ahead and build these container images, change them, deploy them in a very seamless way. So under the hood, let's try and understand what level of isolation containers provide. So all of us know about virtual machines, and we know that virtual machines provide, basically separation at very low levels. So we have the same hardware, but the hypervisor ends up providing isolation between virtual machines, making them very, very secure. Now, in the case of Docker, this is slightly different. What really happens is all Docker or all running containers end up going ahead and sharing the same hardware and the host operating system. So it's only that at an application layer for libraries and above that containerized applications are pretty much in their own little silos. So sharing the same OS kernel, and they use something called namespaces and C groups for isolation and resource allocation. So when we look at Docker security or container security, I'm kind of using both those words interchangeably, then what is the threatscape? So what you'd find is the first, of course, is the registry. This is really where Docker images are stored for use. Then you have the Docker host where these images get pulled, and then containers are created out of these images by the Docker daemon or whatever the container daemon is. On the other side, you have client utilities, which basically use the client-side API to build, pull, run, and issue all of these commands. So now let's actually get into the top 10 threats from our perspective. So what we'd actually find is the very first one is insecure management of the software itself. Now, what is this about? Now, when you look at the Docker client, and this is really where there are so many possible combinations, you'd actually find there are many things which can happen. Now, let's actually jump in to the very first one. So when we look at insecure management of software, what is really happening is there are many softwares which are available which can remotely manage your container infrastructure, like Portainer and others. And this is really where, what we found during our audits is that enterprises have been using, weak passwords. They aren't updating all this management software, and sometimes API endpoints of these management softwares unfortunately remains exposed. So what could be the impact of something like this? Once an attacker unfortunately breaks into one of these management software, he can easily go ahead and take control of all your Docker containers. So the number one tip that we can give you is make sure that your management software is always updated, is completely locked down, and make sure that you go ahead and regulate access to that management software by using a principle of least privilege within the organization. The second one we want to kind of touch about is the exposed Docker socket. So typically, because you are deploying these containers on an entire cluster of servers, what you would find is that management sockets might unfortunately remain exposed. Now, these sockets, if not protected properly, can go ahead and lead to a full server compromise by an attacker taking over the host itself by orchestrating various privilege escalation attacks. So the second tip that we can actually give you is to make sure that your exposed Docker socket is protected, and B, do you even really need to expose it in that format? There are other ways to access a host and go ahead and issue commands on it. Exposing something on a TCP port might not be the best way to do it. Now, the third one is really mounting Docker sockets into containers. Now, this is something, again, is something we found a lot of enterprises end up doing inadvertently, which is the Docker socket is mounted inside a running container. And once an attacker compromises that container, he can end up taking over the host by creating containers on the host and by mounting things like the root file system. So let's actually look at a live demo. And this is something you can try out in our online free labs if you want later. So I'm going to go ahead and show you a quick demo of this. So in this specific demo, what we've done is we've created a Docker container, and inside that Docker container, you have the Docker socket mounted. So, so this is primarily a view from within the container. So now the first thing we do is go ahead, search and see if the Docker socket is actually mounted. And this is something, unfortunately, if an attacker has access to your container, he can do as well. And you can clearly see the Docker socket is mounted on run docker.sock. And unfortunately, because of that, it is actually possible to run your Docker commands from within the container. Now, in this case, what we are doing is we are looking at what are the images available. And now from within the container itself, we can go ahead and create a Docker container on the host, which basically can run in a way that the attacker can take things over. So in this case, what we are doing is we are mounting the root file system of the host into basically this new container. So now by running this, what you'd end up finding is the attacker now has access in the container, and then he can go about looking at the host file system, and based on that, he could do a lot of damage, including, changing files, modifying things, backdooring stuff and whatnot. And that's really what we're showing is, now the attacker is able to look at everything on the host file system itself. So this is something you can easily go ahead and, stop from happening by making sure that Docker sockets are never mounted into containers. Now, where does this typically happen? We found that a lot of Docker management software unfortunately require you to mount the Docker socket into the container so that it can monitor and do other things. In this case, make sure that these containers are very well protected. There is not a web interface through which an attacker could break in and all of that. So now the next part we want to kind of look at is the containers themselves and what could happen. Now, this is really where it is very common, unfortunately, for people to run privileged containers when they actually see that they are unable to do the job with the plain vanilla Docker container. Now, what are privileged containers? And this is basically, a snapshot directly from Docker's website. Now, privileged containers basically allow the container access to devices and a lot of other things, on the host. Pretty much in a way, now you're running with extended privileges, which could be leveraged to take control of the host itself. So if you have a privileged container, for example, running a web server or anything else, and an attacker manages to break in, then he will be able to take control of the host because the privileged container, allows him to do a lot of things he otherwise would not have been able to. So let's look at a demo of how this looks like. So in this demo, what we are doing is we are creating a privileged container, and the user in the privileged container, as you will see shortly, will be able to break out of the container and take control of various aspects of the host. So let me go on a little further. Okay. So now we are inside a privileged container, and the first thing that an attacker would do is basically look at his capabilities using capsh. Now this gives a massive number of capabilities in here, and we can clearly see that he's able to look at the devices simply because he's running on a privileged container and the devices are mapped in. So now what could happen is he could simply just mount the hard disk of the host into the container and get access to all the files. So you can clearly see how easy it is once a privileged container has been broken into to further cause damage. And this is something, as a security tip, we can actually tell you to make sure that do not run privileged containers on internet facing services under any circumstances. And if you do have to run, make sure that those containers are very, very well protected. Because it is extremely easy once an attacker has a foothold into this container to actually break out, take control of the host and do a much larger damage. Now, the next thing we wanted to discuss is containers as capabilities. So privileged containers basically go ahead and gives you, all important privileges, pretty much keys to the kingdom. Now, capabilities are another common place where people make mistakes. So basically capabilities are, kind of broken up permission sets that can be granted to containers in order to do various tasks. So what ends up happening is most administrators do not realize that some of these capabilities are all powerful. And if granted to a container and that container gets, broken into, then an attacker can do a privilege escalation attack to, unfortunately, take over the entire host. So as you can see, there are many privileges out here which you can attach to your containers. Some of them are very powerful, like sys_admin allows you to do admin tasks. sys_module, which we'll actually see in just a bit, is a very, very powerful capability, because this allows you to load kernel modules from the container, into the host kernel. So you can imagine how powerful this actually is. And there are many others which can be abused. So let's look at the sys module capability demo, which is a slightly more involved one. So in this specific demo, we are actually going inside a container which unfortunately has been granted the sys module capability. And what you would find is that this capability allows an attacker, once he compromises the container, to go ahead and create a kernel module and insert it onto the host file system. So, we are in the container, we are looking at the capabilities, we can see that sys module is available, and we look at the IP addresses, and after that, we are going to create a very simple demonstration to show why this could cause a huge problem and a host takeover. So we are creating a simple kernel module, and what this kernel module does is it's going to launch a user space process as root, and the user space process would end up connecting back to an attacker where he can get a shell of the root user on the host system. So right now what we are doing is we are basically creating the makefile for the kernel module compilation. And now we are going to compile the kernel module. And you can clearly see that's really where the reverse shell part is. Now once the kernel module is compiled, you can immediately go ahead and push the kernel module into the running kernel. And this can become very, very problematic. So if you notice now, we are creating a listener from within the container. And now we are going to insert the kernel module because we have sys module capability. The moment this happens, basically the kernel module gets executed into the host's kernel. And from there, it starts a user mode process on the host system as root. And that process basically spawns bash, which ends up connecting back to the reverse shell that the attacker is waiting on within the container. And you can clearly see we've now received a root shell, and this root shell is actually on the host. So based on this, now an attacker may end up doing further damage. So you can clearly see how using sys module capability, your entire host system could be brought down. So this is another important security tip, which is if you use containers and you feel like you need to grant them some additional privileges and capabilities, make sure to do a lot of background research before doing it. Capabilities are not as granular as one would hope them to be, and granting the wrong capabilities would end up meaning that your entire host could get compromised from via your container using a container breakout attack like we just showed. So the security tip here is, as far as possible, avoid using capabilities, just like I mentioned, to avoid using privileged containers. Now, number 6 is sharing host namespaces. Now, as I mentioned, containers are basically created by, separating them out into a different namespace. And this is really where a lot of times when you want to do any form of namespace sharing, it is an extremely bad idea. Now, internally within the kernel, namespaces are used to isolate containers from the host. And that really is all that gives you the protection that containers boast about. Now, going ahead and sharing any of the host namespaces with a container opens up for any form of crossover attack which would end up happening. And that is really where one needs to be very, very careful to make sure that this is something they do not do. Now, tip number 7, privilege escalation with containerd, and tip number 8, privilege escalation with runc. These are two low-level constructs when it comes to the world of containers. Now, most of us are used to using things like Docker to spawn containers or Kubernetes to go ahead and, manage huge cluster of containers. Now, it's important to kind of understand what is happening at the lower levels. So typically your Docker client is going to talk to the Docker daemon running on the container host. Docker daemon in turn ends up talking to low-level daemons like containerd, and containerd in turn is going to use runc to go ahead and create the actual container. Now, these low-level components, if they remain lying around, on a host, can be used for privilege escalation by a low-privileged user to gain access to root on the host. And this is something we found is, you created a Docker host, but you've not protected many of these components, or a Docker host was created and then Docker was removed, but some of these components end up still remaining as remnants and accessible to non-root users. So both of these together, I'm going to show you a quick demo with runc. So let's actually look at that demo. So in this specific demo, we are going to get access to basically a host on which runc is available. And we are a low privileged user. And what we are going to do is, using runc, we are going to see if privilege escalation is possible. So we are looking at runc. and we see that there is runc installed on the system. And you can see right now that we are running a student at localhost, which is a low privileged account. And what we are going to do is, using runc, we are first going to create a specification file. And this is really nothing but a dummy spec file with all the common attributes in there. So we do that by running the command runc spec. Now let's look at this file. Open it up in Vim, and you would find that this is a specification file based on the OCI standard. Now really at the lowest level, when we talk about namespaces, when we talk about allocation of resources, capabilities and all of that, at the lowest level, this specification file is what gets built and is used by runc to go ahead and create the actual container. So you can find that, all the common things that we've been discussing are all in here. There are mount points and whatnot. Now, what could happen? A low privileged user could actually create a mount point to load the root file system of the host into this container and get access to it, right? So in this case, we can clearly see that he's going ahead and mounting a destination / which is basically the root file system. And he's going to load this in a read-write mode. And there are other options, which is rbind and rprivate, which allows him to do other interesting things. Now, once this configuration file has been created, or rather modified to include this parameter, the student user can now create a dummy container using this. Unfortunately, runc, because it has high privileges, would end up mounting the root file system into the container. So you can see now that once we ran runc run demo, basically a container was created and student is in the container. And that container, unfortunately, now has the root file system of the host bound to it, which allows student to gain access to critical files or to go ahead and do other privilege escalation attacks. So as we can see now, we can basically look at the root directory and we can cause much harm. So the important thing here to note that make sure your low-level container constructs like containerd, runc, etc. are not available for use to other users on a multi-user system, right? At the very same time, if an attacker unfortunately breaks in on a web server which has these, he may be www data, but if he has access to any of these, then he could use them to go ahead and do privilege escalation. Finally, the registry itself. I think the registry itself ends up being insecure at times, as we've seen in our audits. Unfortunately, a lot of people seem to create private Docker registries in development environments, and sometimes even put them out in production environments, not understanding that these are very easily compromisable. And once these are compromised, an attacker can backdoor images and take control of servers where these images are automatically getting pushed or run, or servers where images are automatically updated when the registry gets updated. And this is also something, as a security tip, we can tell you, leave something like Docker registry, to the experts. Use something like Azure's registry service, something which is well maintained and protected, rather than reinventing the wheel. Last but not the least, Docker images themselves, right? The way you create Docker images, one has to understand that there could be secrets embedded in these Docker images. Now, as some of you might know, Docker images are nothing but a series of file system layers, one over the other. And finally, the top layer is the one which is read-write. Everything below is read-only. Now, as someone building different layers, you're creating files, destroying them, copying things, and at the very end, you have, the final image. Now, do not make the mistake of thinking that this final image is what that gets shipped. Anyone with access to the Docker image can peel through each of these layers and can quickly see what is in each layer. So from a forensic standpoint, this is very, very disastrous to an organization if they do not make sure that the users have their users have created these layers in a way which does not leak any secrets, any API keys, or any of that, if someone had access to this image. And this is very common because a lot of organizations end up sharing their Docker images via public repositories to share with others. And a common mistake like this can happen. So we would say that make sure Docker images are created, using a well-defined process where someone with a security background can double check and ensure that no secrets are leaked. So thank you so much. This is basically all I had from a top 10 perspective. So hopefully these top 10 tips to enhance your cloud container security is useful. Feel free to reach out to me if you have any further questions. I'm vivek@pentestacademy.com. Would love to talk security at any time. And thank you, Microsoft, for giving me the opportunity to basically speak at this great event. Thank you.
I'd like to thank you for spending your time with us throughout the day. You've heard about the history of DevOps and how it's transforming industries and organizations, how we've applied these principles at Microsoft, and you've heard from companies like Chipotle and Petronas on their own DevOps journey. Also, a lot about the tools, processes, organizational change that needs to happen so that you can speed your own digital transformation journey when it comes to DevOps. Now, one of the things I want to put out there for you is how Microsoft can really help you on your DevOps journey if you would like. We have a link here that you can see. You just have to scan the QR code that is on your screen right now, and it'll take you over to this developer velocity assessment. You heard me speak at the beginning of the day that there's about 40 plus measures that come into measuring where you are in your maturity of your DevOps journey. And this will help you get started in thinking about where do you want to apply your energy, whether it's in the tooling, whether it's in the process, or whether it's even in the left to right view of what you need to do in order to land developer operations at your company. So thank you again for spending your time with us, and please have a wonderful rest of the day no matter where you are on behalf of Microsoft, and thank you again.